Can a planet be bigger than its parent star? Well, if you mean a star like our Sun, it's highly unlikely. But what if it was a white dwarf, the remnant of a star similar to ours that went out after shedding its outer layers and leaving behind nothing but the core? This core is what we call a white dwarf. Usually, it's around the size of our home planet. If a star had a planet bigger than Earth before it extinguished, it's possible that such a planet could survive all the chaos. In this case, a planet that is bigger than its star might actually exist. And we've even found planetary systems like this. But there's one problem. A white dwarf isn't a real star like our Sun anymore. It doesn't produce energy, just sits out there getting cooler and cooler. So probably such systems don't count. For comparison, the Sun is working non-stop. It is fusing hydrogen into helium in its core. It has been doing it for more than 4 billion years and is going to keep doing it for the next 7 or 8 billion years. The Sun is 10 times as wide as the largest planet in our solar system, gas giant Jupiter. And sadly, you can't get a planet much larger than that. If you start adding mass to such a world, it will get smaller, not bigger. So it seems you can find a planet larger than the Sun. But there are also dim red dwarf stars. They're the smallest out there, barely massive enough to maintain fusion in their cores. The tiniest stars that we know about have been discovered recently. If astronomers' conclusions are correct, then both of them can hardly fuse hydrogen into helium. And it takes about 0.077 times the Sun's mass, or 75 masses of Jupiter, to be able to do that. And still, they're real stars, just very tiny, smaller than Jupiter. One of them is only about the size of Saturn, which must mean that stars can have planets bigger than they are, right? Well, theoretically. When it comes to practice, you can hardly find such planetary systems. We've found and observed quite a lot of exoplanets, which are worlds orbiting other stars. It seems that there are indeed loads of trends out there in space, different masses, sizes, brightness, and so on. But the main trend? Red dwarfs don't usually have gas giants orbiting them. If they do have planets, those are typically small, rocky worlds, more like Earth. Those are also called terrestrial planets. For example, a red dwarf called TRAPPIST-1 has 7 Earth-sized planets orbiting it. But gas giants circling around red dwarfs are extremely rare. Hardly 1 in 100 tiny stars can boast such a planet. This number can be even smaller since the research has been done using candidate planets which haven't been confirmed yet. Plus, the smallest stars are also the dimmest. It means they are extremely hard to detect, and it's incredibly hard to figure out whether they have planets orbiting them, and if they do, whether these planets are gas giants or terrestrial worlds. Still, it's possible that a system where the planet is larger than its parent star exists. But the probability is statistically very low. At the same time, red dwarf stars are very numerous. They're actually the most common kind of star in the galaxy, making up around 70% of all stars. And even though really tiny red dwarfs are relatively rare, there still must be millions or probably even billions of them in the galaxy. And if there's even a small fraction of red dwarfs with gas giants orbiting them, it might still mean that a lot of such systems exist in total, and some of them can have planets bigger than their host star.
Imagine a being so powerful it can suck in entire galaxies, so mysterious it's invisible to the naked eye, and so impressive it bends the very fabric of space and time to its will. Yes, meet my mother. Just kidding. Actually, meet the ultimate superhero of the universe, the black hole star. What is it and how does it work? Well, let's find out. The universe is full of marvels, and the black hole star is one of the most impressive ones. It's a supermassive force that can bend the laws of physics, and a true enigma for scientists to unravel. No wonder science fiction writers find them so captivating. A black hole star, also known as a quasi-star, is a hypothetical type of extremely massive and luminous star that may have existed early in the history of the galaxy. They're predicted to be as luminous as a small galaxy, but unlike modern stars, they weren't powered by nuclear fusion in their cores. A quasi-star's energy would come from material falling into a black hole at its core. And yes, just like a normal black hole, these stars have the power to suck in anything and everything that gets too close, including stars, dust, and even entire galaxies. But how is it possible that the star is born from a black hole? And what's more, how do they continue to coexist together? Well, first let's discuss how black holes are born in general. It all starts with a supermassive star, one that is at least a few times more massive than our own Sun. This giant of a star burns bright and hot, shining with the light of 1,000,000 suns. But eventually, it runs out of fuel and its fate is sealed. As its lifespan comes to an end, it makes one final massive boom, a blast so powerful it can outshine an entire galaxy. This blast is called supernova. During this boom, the outer layers of the star fly away, while the core gets squished together by its own gravity. If the squished core is heavy enough, it can keep squishing until it becomes a black hole. And just like that, a black hole is born. Don't even try to put diapers on this thing. Now, this cosmic monster baby can continue to grow by swallowing up anything that comes too close, including stars, dust, and even entire galaxies. This is basically what's happening now in our universe with supermassive stars. But what about quasi-stars? The formation of a quasi-star could only happen early in the development of the universe, before hydrogen and helium were contaminated by heavier elements. And because of that, quasi-stars have one important feature. They are gigantic, so enormous that it's literally impossible to imagine. They may have been dwarfing even the largest known modern stars, like VY Canis Majoris and Stephenson 218. No wonder they're so scary. They were born from protostars, one of the first stars in the universe, the great-great-grandfathers of, everything. So now, imagine a protostar so massive that its core collapses into a black hole, just like we described before. But the key difference is that in a regular supernova, the outer layers of the star are blown away by the energy released during the boom. Meanwhile, in a quasi-star, these outer layers are massive enough to absorb the energy without being blown away. What do we get in the end? A star with a black hole in its core that weighs from 1,000 to 10,000 solar masses. This quasi-star is about 14,000 times bigger than our Sun, which makes them bigger than any star we know today. These celestial titans have some pretty crazy properties. Once a black hole is formed at the center of a giant protostar, it starts to give off a ton of energy. This energy helps to balance out the force of gravity, making it kind of a giant fusion-based star. They would be so bright that each one would look like a small galaxy. Quasi-stars would have a pretty short lifespan, around 7 million years. Just for comparison, our Sun is about 4.5 billion years old, and it's only halfway through its lifetime. But either way, during this short period, the black hole at the center would grow to be about 1,000 to 10,000 times the size of our Sun. Quasi-stars are also thought to be super hot, with temperatures reaching over 17,500 degrees. But as a quasi-star gets older, it starts to cool down, and its outer layers become see-through. Eventually, it cools down to a temperature of 6,740 degrees, and at that point, it's curtains for the quasi-star. It can't survive at that temperature, so it just dissipates, leaving behind an intermediate mass black hole. Unfortunately, right now, there's no observational evidence for the existence of quasi-stars. This is because they're thought to have only existed a very, very long time ago. They may have been very massive population 3 stars, which are extremely rare and difficult to detect. It's also very unlikely that any of them would still exist today because of their super short lifespan, only 7 million years. So why do scientists believe that quasi-stars could have existed? Because they're looking for ways to explain how supermassive black holes formed so early in the history of the universe. They're found at the center of most galaxies. But how could these monsters have formed so quickly? After all, it takes a really long time for small black holes to grow into supermassive ones. This is where the idea of quasi-stars come in. These stars aren't just destructive forces of nature, they're like the black belts in the martial art of gravity. They can bend and twist anything to its will. That's why these stars, if they really existed, had to play a crucial role in the evolution of galaxies. They must have been instrumental in shaping the universe as we know it. So, those intermediate-sized black holes that they left behind could eventually turn into supermassive black holes in the center of galaxies. But we're still yet to solve this cosmic mystery. Detection and study of black hole stars is like trying to find a needle in a haystack. Only instead of a needle, it's an invisible and mysterious object. And instead of a haystack, it's the vast expanse of space. But with the help of some pretty cool technology and a lot of brain power, scientists are getting closer to uncovering the secrets of these celestial giants. Here are some things that can help us in this research. First of all, gravitational waves. They're like ripples in the fabric of space-time, caused by the movement of massive objects. Albert Einstein predicted them way back in the 20th century, but they were finally detected only in 2015. We caught them by observing the collision of two black holes. This discovery confirmed that black holes can merge and that they're a powerful source of gravitational waves. Scientists think that by studying these waves, they can learn more about how black holes form and grow. We can also try to detect quasi-stars by observing the effects of their gravity on nearby objects. It's like trying to spot a criminal by their fingerprints. For example, if a black hole is located near a star, scientists can observe the star's light being distorted as it's pulled toward the black hole. And of course, we can use our technologies, such as X-ray, infrared, and radio telescopes. This allows us to study black holes in various ways and at different stages of their lives. In other words, scientists are working hard to uncover the secrets of these celestial giants. We develop new telescopes, search for primordial black holes, and try to understand the connection between black hole stars and dark matter. And we're making some pretty incredible discoveries, just like with gravitational waves. All these things will bring us closer to uncovering the secrets of quasi-stars. And when we find out the truth about them, it will become a new page in our scientific history. Now, it's been a long time since there was a supernova in the Milky Way, over 400 years to be precise. So hey, we're long overdue. So here are the most likely stars to go boom, if they haven't already. At the top of the list must be the Southern Hemisphere star Eta Carinae. Greek letters before the name of the constellation indicate the rank of the star's brightness in that constellation. Sir Edmund Halley, in 1677, recorded Eta Carinae as the seventh brightest star in the constellation Carina, Eta being the seventh letter in the Greek alphabet. It might not have looked very bright to Sir Edmund and his contemporaries in the 17th century, but modern studies of Eta Carinae estimate it's 5 million times more luminous than our Sun. Luminous is a technical word astronomers use. It doesn't just mean brightness. Luminosity refers to the total energy released at all frequencies. Eta Carinae releases 5 million times more energy than the Sun. Truly one of the whoppers of the Milky Way, Eta Carinae is 100 times more massive and 240 times larger than our yellow-white dwarf sun, Sol. Obviously, since it appears dim, Eta Carinae is pretty far away, about 7,500 light-years away. Yet even at this distance, if this star goes hypernova, it can still impact Earth's ozone layer, disrupt satellite communications, and harm astronauts. 159 years after Halley's observation, Eta Carinae experienced a nova-like explosion. It increased from a relatively dim star to become the second brightest star visible from Earth, but only for a period of 27 years. From 1836 until 1863, Eta Carinae was the second brightest visible star after Sirius, the dog star, and Sirius is only about 8 light-years away. Since 1863, aside from a couple of flare-ups, Eta Carinae has dimmed back down to its original brightness at magnitude 4.5. Now, astronomers owe us a small apology, which we don't expect to get anytime soon, for star magnitude nomenclature. The brighter a star is, or planet, or moon, the lower its magnitude. Thus, stars brighter than first magnitude are either zero magnitude or negative magnitude. The full moon, for example, is magnitude negative 13. A magnitude positive 4.5 star, like Eta Carinae, is quite dim as seen from Earth, but it's clearly visible in a night sky without light pollution or clouds if you live anywhere south of the latitude of Cairo, Egypt. 30 degrees north latitude is the farthest north you can see this star. Now, listen up. Eta Carinae is currently up to something. It's been brightening again and is now brighter than at any time since 1864. It's a complex situation. Eta Carinae is really two stars, Eta Carinae A and Eta Carinae, what's your guess? Oh, B. There's a third star nearby that's also interacting with the double star's dynamics. Now, without looking, I'm guessing it's named Eta Carinae C. Good guess. Blown out into two incredibly massive globes of gas that are expanding at 20 million miles per hour, Eta Carinae is, without a doubt, one of the strangest looking stars you'll ever see. Remember, it's located at a great distance of 7,500 light-years away from us. And if anything had happened to Eta Carinae in the last 7,500 years, like going hypernova, we wouldn't be able to see it, because none of Eta Carinae's electromagnetic radiation would have gotten here yet. Astronomers are keeping a close watch on Eta Carinae because it can go hypernova at any time. Or maybe it already did 5,000 years ago, in which case we'd only have to wait another 2,500 years to see it. Yeah, like I'll put it in my planner. Now, from a list of over 30 likely candidate stars that might go supernova, Rho Cassiopeiae is many astronomers' choice. Another Greek letter, Rho, is the 17th letter in the Greek alphabet. It means that Rho Cassiopeiae is the star with the 17th brightest apparent magnitude in the constellation Cassiopeia. Yet Rho Cass, a nickname, is only one of 7 known yellow hypergiant stars in the Milky Way. It's another whopper. To be seen at magnitude 4.5 from a distance of about 10,000 light-years away, Rho Cass must be a very large star, a hypergiant. Placed where the Sun is, Rho Cass would encompass the orbit of Mars. But it's still yellow. It's not a red giant star. Red indicates a cooler surface temperature. Rho Cass, as huge as it is still as hot on its surface as our Sun, or even a little hotter. That can only mean two things. Deep inside its core, Rho Cass is fusing atoms much heavier than hydrogen or helium. Plus, Rho Cass is producing much more energy than a red giant star. In the year 2000, Rho Cass erupted massively. It brightened by 2 orders of magnitude as it ejected 10,000 times the mass of Earth into space at 4 times the speed of sound. Astronomers detected the signature of titanium oxide in this eruption. This means that Rho Cass is much closer to going supernova, or in this particular case, hypernova, than astronomers used to assume. Iron is just a few steps above titanium in the periodic table, and when iron forms, fusion stops and a star collapses. Rho Cass is really close, or more correctly, was really close. Because the eruption we saw in the year 2000 really happened 10,000 years before, many astronomers think Rho Cass has already gone hypernova, formed a black hole, and doesn't even exist anymore. Meanwhile, Betelgeuse caught everyone's attention not so long ago. The star, not the movie. It dimmed dramatically, appearing only 37% as bright as it usually is. Is it getting ready to go supernova? Betelgeuse is by far the brightest star in the whole sky, in infrared light. This is an important fact because it relates to Betelgeuse's status as a supernova candidate, as we shall soon see. Betelgeuse is also named Alpha Orionis, another Greek letter designation. So we should conclude that Betelgeuse is the brightest star in Orion, right? Wrong. It's the second brightest star in its constellation. Rigel, or Beta Orionis, is the brightest one in that region. Figure that one out. It may be because Betelgeuse is classified as a semi-regular variable star, which sounds kind of redundant to me. Its approximately 400-day cycle of pulsation changes its brightness by about 1 full magnitude, going from much brighter than a first magnitude star to closer to a second magnitude star. But never was Betelgeuse observed to dim so rapidly or so drastically as it did recently. So what's going on with it? Well, from late 2019 to mid-2020, Betelgeuse went through a period of substantial dimming during a mass ejection event. The world astronomy community jumped on the situation, and in the course of their investigations, they came up with some surprising new factual data on Betelgeuse. First, Betelgeuse is not as far away as we once thought. The new, more accurate distance for Betelgeuse is 548 light-years. That's 25% closer than previously measured. The second new fact, Betelgeuse's diameter has been reduced by the same percentage. The star is now known to be 25% smaller than previously believed. The cause of Betelgeuse's dramatic dimming was also determined. The giant star ejected a cloud of gas that contained magnesium. The cloud blocked a large portion of the light coming from Betelgeuse and made it appear visually much dimmer than it really was. Magnesium is not halfway to iron on the periodic table, which means Betelgeuse is not as far along on the path to a supernova as was suspected previously. When iron starts forming in the star, it means that this star is close to shutting down its fusion reactions. The next step is implosion. We aren't quite there yet with Betelgeuse. This star emits most of its energy as infrared light, and it also indicates that its core is most probably still burning helium, and not something that would greatly increase the amount of heat, like carbon for instance. Betelgeuse will still go supernova, but not for another 100,000 years. So you can cross it off your supernova list for the time being. And as for how to correctly pronounce Betelgeuse, you can say it any way you like. There are as many different pronunciations out there as there are people who think they know how to pronounce it correctly. Now, supernova 1987A caught astronomers off guard when it lit up the Large Magellanic Cloud 100,000 plus light-years away from the Milky Way. That's when attention was turned to a similar star much closer to Earth, Rigel, in the constellation of Orion. Could Rigel surprise us and suddenly go supernova? There's something called the supernova problem that you should, probably know about because it may relate to Rigel going supernova or not. It seems that stars over 17 solar masses don't always go supernova. Recently, a red giant star simply vanished. Once again, it didn't go supernova, it disappeared. This had often been happening in computer simulations of supernovae, and now it finally occurred in real life. Rigel's mass is 21 solar masses. In other words, it's 21 times more massive than our Sun. So, will Rigel go supernova or simply vanish into a black hole that it'll create in its core? Astronomers and physicists continue their work of learning more about the dynamics of massive stars, scouring the sky for the next supernova in the Milky Way. Meanwhile, we can rest confident that we on Earth are in no danger from the harmful effects of nearby supernova explosions. We live in a nice, quiet, peaceful stellar neighborhood, except for those Martians next door.
Betelgeuse, a red supergiant. This ball of boiling plasma is one of the largest stars in our galaxy and one of the brightest. It's about 500 times larger than the Sun. But Betelgeuse is pulsating, getting bigger and smaller. At its peak, it becomes 800 times its average size. If this star were a bucket, it would fit about 300 million suns, even though its weight is only 17 times greater. And here, about 500 light-years away, is Earth. We launch our faster-than-light spaceship and set off on our journey to Betelgeuse. A few seconds, and we've already traveled 240,000 miles, and now are close to the Moon. That's 9.5 trips around the Earth. A traditional rocket-powered spacecraft would take 3 days to get here. We're near Mars now. The flight to the red planet usually takes about 7 months. Several rovers are now at work here, as well as the first ever flying drone, Ingenuity. The surface of Mars is 3 times smaller than that of Earth. The planet is also 10 times lighter. People hope to build a human colony here soon. Right beyond Mars, we have to wiggle and constantly dodge space rocks. This is the asteroid belt. It contains debris and space objects of different sizes and shapes. The biggest of them is Ceres. Its surface is slightly larger than the area of Argentina, and its weight is about 1% of the Moon's. The total weight of the entire asteroid belt is 25 times less than the Moon's. Next, we pass gas giants Jupiter and Saturn. These are the largest planets in the solar system. They're also the heaviest, even though they don't have a solid surface. Then we travel by Uranus and Neptune. They're called ice giants. And at the very edge of the solar system, we see Pluto. It was once considered a full-fledged planet, but now it's not even on the list. After that, we're 4.3 billion miles away from our home. It took the New Horizons space probe about 9 years to get here. Hold on to your seat, we're speeding up! We're passing through the Kuiper Belt. There are lots of asteroids and blocks of ice here. These are some of the oldest building materials in our solar system. Billions of years ago, our whole world looked like a cloud of these asteroids. We're traveling further through dark space and reach the edge of the solar system, the heliosphere. All this time, we've been moving with the solar wind, but now it starts to slow down, collides with the interstellar wind, and heats up. This is called the termination shock. The Voyager 1 space probe got to this point in December 2004. We're moving to the region where the heliosphere ends and interstellar space begins. This is the heliopause. In 2012, Voyager crossed this boundary and became the first ever human-made object in interstellar space. But the message from Voyager reporting this event came to Earth almost a year later because of the huge distance. It took 35 years for Voyager 1 to travel all this way. And here it is. The probe is as long as a car and weighs like 2 motorcycles. You can see a gold plate on its hull. It's a message from people to potential civilizations out there. It has pictures of Earth's landscapes, recordings of human speech, and our DNA. As of 2021, Voyager has been operational for almost 43 years. The probe has traveled 14 billion miles. That's like 152 Earth to the Sun distances. And it's still making its way through space at 38,000 miles per hour. Now, we're approaching the nearest star to our solar system. It's Proxima Centauri. We're so far from home that even light needs more than 4 years to travel this distance. If we used a traditional rocket, the trip would take us 73,000 years. The reason we wanted to get here was because of an Earth-like planet called Proxima Centauri b. It's 10% larger than Earth and slightly heavier. It lies in the habitable zone of its host star. It means that water might exist on the planet in its liquid state, and there can be life that forms here. But the star itself occasionally produces flares. Recently, its brightness increased almost 1,000 times. During that time, it emitted so much radiation that even if there were some forms of life on the planet, they probably ceased to exist. We're now more than 8 light years away from Earth. The brightest star in our night sky is Sirius. Seriously. It's so bright that you can see it even during the day. But in reality, there are actually 2 stars, Sirius A and B. They orbit around a common center of gravity, and these stars are moving toward our solar system at almost 5 miles per second. That's the same as the maximum speed of a top-of-the-line supercar on Earth. Foot down, and we've arrived at a potentially habitable planet, 39 light-years away from Earth. This is TRAPPIST-1d. Its host star is a white dwarf. It's a cold star, 10 times smaller and lighter than the Sun. There are 7 planets around it, but TRAPPIST-1d is the most similar to Earth. It's only 30% smaller and 3 times lighter, but it has a rocky surface and the temperature here is 48 degrees Fahrenheit. You'd feel comfortable here wearing a light jacket. There might be an atmosphere, mountains, seas, and oceans here, which means this planet might be suitable for a human colony. But it would take about 677,000 years to get here using traditional rockets. And here's our main goal, Betelgeuse. It'd take nearly 8.7 million years to travel here from Earth in a current-day spacecraft. This star is so big that our ship looks like a grain of sand on a giant beach. We have to jump back in time to find out what happened to this star. First, there was a beautiful nebula. It's a cloud of multicolored space dust and debris. Then, it began to shrink under its own weight. In the core of the nebula, a nuclear reaction began. Boom! And the star was born. At first, Betelgeuse was very massive and hot, but it didn't expand and remained stable. Let's look into its heart. The nuclear reactions in the star's core create a lot of heat and energy. This energy produces the force that pushes on the walls of the star from the inside and causes it to expand. But at the same time, the star is very heavy. That's why gravity pushes on it from the outside. If these two forces are balanced, the star remains stable. But over time, the star runs out of its fuel, helium and hydrogen. That's when heavier elements in the core join the nuclear reaction. When they burn, they release more energy and heat than gravity can hold, and the star starts expanding. That's what's happening to Betelgeuse right now. It's already so big that if you put it in the center of our solar system, its edge would touch the asteroid belt between Mars and Jupiter. Betelgeuse will continue to expand until it exhausts its fuel completely. Then the gravity will win. The star will shrink in size, and then an enormous boom will happen. A supernova explosion will be so blinding that Betelgeuse will shine brighter than the moon in the night sky. Luckily, Earth is too far away for this explosion to cause any harm to people. A strong stream of matter that will be ejected from the explosion site won't reach the solar system until 6 million years later. Even so, the solar wind will stop this flow, so we'll be safe. Betelgeuse is likely to explode at any time in the next 10,000 years, but some scientists say it won't happen in the next 100 millennia. Back to the moment before the explosion of Betelgeuse, there can be another, more interesting scenario. Gravity might compress the massive core of the star with such force that a black hole will appear in its place. Black holes are the heaviest objects in the universe. They have incredible gravitational force. Even light can't escape their gravitational trap. The Betelgeuse black hole will begin feeding on cosmic dust and whatever is left of the star. All this debris and light from other stars will get frozen near the event horizon of the growing black hole. For the first time in history, we'll be able to watch the birth of this mysterious object. But in reality, Betelgeuse is too light to become a black hole. Most likely, after the explosion, it'll turn into a white dwarf that will gradually fade until it becomes invisible.
You shouldn't have made that bet with your friends. Now, your spaceship is hovering just over the atmosphere of Jupiter, a gas giant and the largest planet in our solar system. You're staring at the ginormous pale yellow sphere in front of your eyes, dreading your task, which is to fly through the planet and leave on the other side. Doubts are plaguing your mind. Is it even possible? Well, you're about to find out. Jupiter is truly massive. If the planet was 80 times as massive as it is now, it would have a chance to turn into a tiny red dwarf star. But even though its size isn't enough for such a transformation, Jupiter is still huge, more than 89,000 miles wide at the equator. The planet is so large it could fit inside 1,300 Earths. It's also impressively hot, about 43,000 F at the core. If you decided to parachute into Jupiter, you would never land on a firm surface because the planet mostly consists of gas. Around 90% of the planet's atmosphere is hydrogen. The remaining 10% is made up of helium with tiny traces of other gases. The planet is also surrounded by a layer of thick brown, yellow, red, and white clouds. They make Jupiter look colorful and beautifully striped. There's no solid ground on the planet. That's why astronomers define the planet's surface as the point where the atmospheric pressure equals that on Earth. You wouldn't be able to stand on that surface, though. It's just another layer of gases. But the gravitational pull there is around 2.5 times more powerful than on our planet. The deeper you dive, the more difficult it gets to move. Under immense atmospheric pressure, hydrogen and helium gases turn into a dense fluid. Closer to the core, this liquid becomes a mixture of metallic hydrogen and helium, which makes this region as exotic as the surface of the sun. Now, to imagine the gigantic pressure that exists near the center of Jupiter, think of the deepest place in Earth's oceans, the Mariana Trench. It's nearly 7 miles deep, and pressures there reach more than 1,000 bars. For comparison, at sea level, you feel the pressure of approximately 1 bar. But that number doesn't seem all that impressive when you think about the pressure at the center of Jupiter. It reaches up to 1 million bars. So, if you tried to enter that region, your spacecraft wouldn't just get squished or melted. No, it would simply disintegrate into atoms. You won't even have time to say, "Oops!" If you still decided to take the plunge, you'd have to go through different parts of the gas giant. First, you'd see wispy ammonia clouds. You might even enjoy a brief period of blue skies, due to the same phenomenon of scattering of light that occurs on Earth. After that, you'd pass through some red-brown clouds. Those are made of ammonium hydrosulfide. And then you'd see intimidating towering clouds lit by constant lightning storms. Way deeper, between 4,350 and 8,700 miles down, your spacecraft would enter an atmosphere so hot that it would be glowing. This is where the temperature rises up to tens of thousands of degrees F, and the pressure rises to megabars. That's also where your spacecraft is likely to start to disintegrate. This is a mysterious region of Jupiter's interior we know little about. It's still unclear whether the planet's core is a molten ball of liquid or a solid rock more than a dozen times the mass of Earth. It's most likely the former. There's even some evidence the gas giant's core might be melting right at this moment. Scientists have suggested that it consists of a mixture of materials, including nitrogen, carbon, and even iron. In any case, not to risk your life, you'd better admit you've lost the bet and return to your hospitable home planet.
When you explode planets, things get red hot. Atmospheres are pulled away. Stuff is flying apart. Everything collapses. The world becomes brighter than a dozen suns. You squeeze your eyes shut and cover your ears. Your hair stands on end. The sheer power of a cosmic blast is terrifying. But how can you do it? How can you blow up, let's say, Jupiter, the largest planet in our solar system? Thick brown, yellow, red, and white clouds hide its surface, making the planet look colorful and beautifully striped. First of all, we shouldn't forget that the gas giant's powerful gravity is holding it together, which is the reason for the planet's spherical shape. And we would need to add a lot of energy to blow it apart. But here's the problem. If we used some explosive material for our goal, it wouldn't be very efficient. A lot of energy would get radiated as heat in the process. The mass of Jupiter equals 318 Earth's masses and about 1,000th of the mass of the Sun. The gas giant's diameter is also more than 11 times greater than that of Earth. It would be around a quarter of the distance from Earth to the Moon. So, can you imagine the enormous binding energy that keeps Jupiter together? Now, experts claim that to explode this space giant, you'd need a pile of nuclear explosives as heavy as 4 moons. Can you imagine it? Or let's take another unit. A highly explosive material known as TNT. How much of it would you need to blow up Jupiter? The answer is 50 megatons. And 1 megaton is 1,000,000 tons of TNT. These are some huge numbers. They also mean that if you made Jupiter out of TNT and blew it up, the explosion wouldn't produce enough energy to blow the planet itself apart. It would puff up more and more. But gravity would still manage to pull all the stuff Jupiter is made of back together. But let's suppose you somehow managed to find an enormous amount of explosives that would be enough to get rid of Jupiter. You hit the button, sitting in your spacecraft, hovering over the giant planet. Something is going on down there on Jupiter, but it's unlike anything that would happen to a rocky planet. Instead of chunks of solid crust, you see jet streams of gas accelerating away from the planet's center. It's what used to be Jupiter's atmosphere, made up of hydrogen and helium gas. In no time, the matter hurtling away into space turns liquid. That's hydrogen in its different form. Under immense atmospheric pressure, this gas becomes liquid closer to the center of the planet. A bit later, you notice that the liquid becomes different again. Now, it's a mixture of metallic hydrogen and helium. And finally, something solid. It might be Jupiter's core, which is 14 to 18 times the mass of Earth. The blast lasts no more than half a second. And still, the explosion is millions of times brighter than the sunshine. It's so powerful, it evaporates smaller planets like Mars and Earth. The sun remains pretty much untouched. It gets hotter and kinda unstable for a bit. But it doesn't last long. How would the disappearance of Jupiter affect our solar system? For one thing, this gas giant shepherds the asteroid belt. And without Jupiter out there, the belt might grow unstable. It would lead to an increase in the amount of debris invading the inner solar system. Plus, the gas giant also acts as a sponge, absorbing rogue chunks of rock and not letting them enter the inner solar system. So it's great that Jupiter is practically indestructible, unless it collides with an object as huge as the Sun, of course. Or you could probably scoop the planet up a bit at a time. It would certainly take a while. One hypothetical project called a Jupiter brain suggests taking Jupiter apart and turning it into a planet-sized supercomputer. And you know what? Some advanced technological civilization could probably do it, but not us humans yet.
Jupiter, the fastest spinning planet in our solar system, with a day lasting only 10 hours. The biggest planet in our solar system, a gas giant more than 300 times as massive as Earth. It has rings of dust and colorful bands stretching across its surface, which are actually gases. And then there's the Great Red Spot, iconic raging storm, huge hurricane, 2 to 3 times as wide as the whole Earth. It's also insanely deep and goes around 300 miles into Jupiter's atmosphere. That's 40 times as deep as the Mariana Trench, the deepest oceanic spot on Earth. Way more extensive than scientists expected. Researchers have speculated about the Great Red Spot for hundreds of years already. This storm is circling Jupiter in its southern hemisphere. At the center of this giant spinning storm, the winds are relatively calm. On the edges, wind speeds go up to 425 miles per hour. That's twice as faster than the strongest hurricanes on our planet, 175 miles per hour. When there's a hurricane on Earth, it goes wild at first, but eventually starts to slow down. It finally breaks apart when it reaches solid land. Jupiter has a sky that's 44 miles deep. There are layers of clouds, and beneath them, scientists believe, lies an ocean of liquid hydrogen. The planet's core is supposed to be right under that ocean, but we're still not sure what exactly it's made of. As far as we know, Jupiter is a gas world, so there's no solid ground that would stop the storm. That's why the spot continues to rage on and on. Scientists realize the storm is constantly changing its size. Compared to data from 1850, it's shrinking right now. The Great Red Spot used to be 3 times the size of Earth. It's been a long time since it last got bigger. As it's shrinking, the storm gets taller and changes color into an intense orange, possibly because of the chemical reactions. New matter raises from the bottom of the storm. The red Great Spot could continue shrinking and eventually disappear in the next 10 to 20 years. But there could be another similar storm emerging somewhere else on Jupiter, if the red Great Spot ever ends. This storm might seem very deep, but it's still shallower than the giant jets of wind that rage around it and power the storm even more. Jupiter's bands of wind go to depths of 2,000 miles below its cloud tops. Jupiter is generally known for having crazy windy conditions in the upper and lower parts of the atmosphere. The middle part is called the stratosphere, and we didn't know what was going on there. Scientists usually measure wind power by watching clouds, and there are no clouds in the stratosphere. But when a comet, Shoemaker-Levy 9, collided with Jupiter in 1994, scientists got a chance to study cometary structure and composition and its effects on Jupiter's atmosphere. They discovered insanely strong winds in the stratosphere with speeds of 900 miles per hour. Jupiter isn't the only planet in our solar system with crazy weather. Mars has the biggest dust storms amongst all 8 planets. When such a storm is raging, it seems like it creates a blanket over the entire planet that lasts for months. One theory that tries to explain why dust storms are so big on Mars says airborne particles of dust absorb sunlight and warm the planet's atmosphere. This creates warm pockets of air. They start flowing toward colder areas, which then generates winds. These winds lift dust off the ground, which heats the atmosphere, makes winds stronger, and kicks up more dust. Mars generally has a very thin atmosphere. It mostly consists of carbon dioxide, and the volume of gases in the Martian atmosphere is less than 1% of that of our planet. But Mars used to be much wetter and warmer than it is today. That means its atmosphere was much thicker. A long time ago, it created a strong greenhouse effect and trapped the sunlight. Mars used to have a pretty strong magnetic field. Just like on Earth, the magnetic field on Mars was created by currents of molten metals in its core. But unlike our planet, the inside of Mars cooled enough to switch off the magnetic field. Without it, Mars wasn't protected from the solar wind. That's a powerful stream of particles flowing from our sun. It took only a couple of 100 million years, which is not much in space terms, for the solar wind to strip away most of the atmosphere on Mars. It went quickly because the sun used to rotate much faster at its earlier stages, so the solar wind was more powerful and energetic. And that's how Mars turned from a planet with a warm, wet climate into the cold, dry place it is today. Mars also has some interesting glaciers. They've been on its surface for hundreds of millions of years and can tell us secrets of the planet's past. For instance, that's how we found out Mars went through 6 to 20 separate ice ages during the past 300 to 800 million years. Satellites took images of 60,000 rocks of different sizes. They were distributed across the entire planet at random. If Mars had a single, long ice age, we'd find a progression of bigger to smaller rocks because they erode as time goes by. But the rocks were spread in clear bands of debris across the surface of these glaciers. Each band marked a different flow of ice, which means each of them formed during a different ice age. These glaciers are like time capsules because they could have all kinds of gases, rocks, or even microbes trapped inside. That means they could help us understand the changes in climate on Mars and tell us if there used to be any form of life on the planet. And the best thing, we don't need to drill deep down below the crust to find that out. Everything's on the surface. If you could go back in time, let's say 4 billion years, and visit the red planet, you'd probably see chaotic scenes of flooding. Scientists believe that megaflood happened because of a huge meteoritic impact. Because of the heat from that impact, ice on the planet's surface started melting. This flood carved out big ripples and waves in the sedimentary rock. Some wave-shaped features are over 30 feet high and spaced out 450 feet apart. Saturn also has its own unique weather conditions. Lightning bolts there can be 10,000 times more powerful than the ones we have on Earth. NASA's Cassini spacecraft was orbiting Saturn from 2004 to 2017. It captured lightning so strong and intense, we could see it even during the daytime. Cassini also recorded the sounds of those intense storms discharged into the planet's atmosphere. From time to time, Saturn has giant storms that go over 190,000 miles across the surface. They encircle nearly the entire planet. On Saturn's North Pole, there's a massive hexagon of clouds. It's a vortex of a pretty unusual shape that circulates hundreds of miles above the clouds and extends deep into the planet. But Saturn has its peaceful side too. Along with Jupiter, Uranus, and Neptune, it has its own beautiful auroras from time to time. All 4 planets have an atmosphere dominated by hydrogen. That's why you can only see these auroras in ultraviolet wavelengths. These northern lights are especially bright at dusk and right before midnight. Venus has a giant storm swirling in the atmosphere at its south pole. The vortex is as big as the entirety of Europe, and it's probably been there for a very long time. The atmosphere on Venus moves 60 times faster than the planet rotates. Venus is the hottest planet in our solar system. Even the rain there offers no relief, since it's sulfuric acid falling from clouds and evaporating before it even gets to the ground. The sun also has its own angry outbursts in the shape of powerful solar storms. These storms bring strong radiation and dust particles that can cause serious damage to satellites that track the sun's activity to let us know if something goes wrong. Every now and then, a crazy solar storm can catch us off guard. About 160 years ago, a strong solar flare caused severe issues in global telegraph communications. About 30 years ago, a solar flare left 6 million people without electricity for 9 hours. One theory says strong solar activity could have caused the sinking of the Titanic. It happened on the same night as a fascinating northern lights show. Some people believe a solar storm behind it had possibly disrupted the ship's communication systems and navigation, leading to one of the greatest unsolved mysteries ever.
You're standing in a room full of explosive gas. One spark could cause an explosion so powerful that all the windows and doors would be just blown out with a huge column of fire. And you're holding a match. You need a bigger target than this room. How about the largest room of explosive gas in our entire solar system? Meet Jupiter. It's the 5th planet from the Sun and the largest one in our system. It's 11 times the width of Earth and almost 2.5 times heavier than all the other planets in our solar system combined. If we put Jupiter on the scales, we would need about 317 Earths to balance it. But most importantly, it has a lot of methane in its atmosphere. It's the gas we use in our kitchen or fill up our car with, and it burns just fine. More importantly, there's metallic hydrogen. In its normal state, hydrogen is the lightest element in the universe. But on Jupiter, it's at great pressure, more than 400 million atmospheres. By comparison, on Earth, you feel the pressure of 1 atmosphere. So multiply that by 400 million, and hydrogen is compressed so much that it looks like liquid metal. Metallic hydrogen can be a great fuel. It'll give off 20 times more energy than burning ordinary hydrogen. So you and your match can have great fun out there. Okay, here we go. The first problem is distance. Jupiter is only 1 planet away from us, but the path is also blocked by the asteroid belt behind Mars. It's full of giant rock debris. On average, each asteroid could be as wide as the distance from Los Angeles to Las Vegas. There's rocks the size of an entire state. And the biggest asteroid of them all is Ceres. It's almost as wide as Alaska. It's even considered a dwarf planet. And this dangerous journey to Jupiter takes about 650 days. That's almost 2 years of boredom inside a spaceship. By comparison, the longest time astronauts have spent aboard a spaceship is 84 days. But we'll let you take your favorite DVD collection and a couple bags of popcorn. At the end of the day, you'll be able to get some sleep after a hard day at work. Fast forward 2 years into the future, and you've arrived at your destination. You're already imagining lighting a match at the surface of Jupiter, exploding it like a balloon. Oh, be careful when you get close to it. Because of Jupiter's great weight, it has a strong gravitational force, about 3 times stronger than back home on Earth. The closer you get to its surface, the weaker you feel, and you can even barely stand on your feet. The maximum weight you can lift here is also 3 times less, and even a match you're holding in your hand already feels heavier. If you try to jump up, you need more effort. Actually, you can't even do that because Jupiter is a gas giant. That means it has no solid surface. Theoretically, the deeper you dive into these clouds, the more pressure you'll feel. Gradually, the clouds and gases thicken and form a kind of liquid. But you don't have to dive that deep. Methane is a light gas, and it's closer to the surface. So, this is the moment of truth. You take a match, you flick it on the box, and nothing happens. Well, let's give it a couple more tries. Second match. Third. Nothing works. Okay, you've got a gas burner in your backpack. You unscrew the valve to maximum, and nothing happens again. Well, that's because it takes 3 components to start the combustion process. The first is fuel. Luckily, there's enough methane and metallic hydrogen on Jupiter to blow up the whole planet in a matter of seconds. The second component is the ignition source. It's the initial force that will start the combustion process. It could be a spark, an electrical discharge, or a match like the one you have in your hand. And the last ingredient is oxygen. Yes, the same oxygen that we breathe. It's just as important to fire as the fuel itself. For an experiment, try lighting a small candle. Now cover it with a glass. You see how the fire keeps burning for a few seconds and then goes out? The fuel is still there, but the fire has used up all the oxygen inside the glass, and the burning process is over. The same thing happens on Jupiter. There just can't be fire, simply because there's no oxygen. And you didn't even have to fly there to find that out. From Earth, we can see hundreds of thousands of little meteorites falling on Jupiter. The asteroid belt next to it is to blame for this. When they hit its atmosphere, they start to burn, and that doesn't instantly blow up the entire planet. But don't be upset. There's still a way to ignite this gas giant planet. All you have to do is trigger a thermonuclear chain reaction on the planet. Then, there'll be an explosion so powerful, it'll be visible from Earth, and it will be like the birth of a new star. To do that, we need to detonate a nuclear reactor, like the ones that give us electricity here on Earth. In fact, we'd have to send everything we have to Jupiter, but even that won't do the trick. Big asteroids, when they hit the planet, cause a much bigger explosion. In 2009, a meteorite the size of 5 soccer fields hit Jupiter. It caused an explosion of 5 billion tons of TNT. This incident left a dark spot the size of the Pacific Ocean. And an even bigger explosion happened there in 1994. After that collision, there was a giant spot on Jupiter, almost the size of our planet. But strong winds and storms quickly began to sweep away the traces of the explosion. After a few weeks, Jupiter looked like normal. The problem is that our attempts to blow up the gas giant took place on the planet's surface. We need to plant a charge the size of the moon, deep below. A massive explosion will cause a thermonuclear reaction and cause the metallic hydrogen to detonate. The explosive process is set, and within seconds, Jupiter explodes like a giant balloon. But this spectacle will be the last one that humanity ever sees. The explosion would disturb the stable orbits of Earth and the other planets. The trajectory of Earth around the Sun might change, and we may see the dawn not in the east, but on any other side of the world. When the strong wind from the explosion reaches the Earth, it'll start scraping our atmosphere. Soon, our planet will lose its ozone layer. It was our shield that protected us from solar radiation. In such a situation, we'll have to hide underground for the rest of our lives. But even this can't protect us. Before long, the Earth will be showered with thousands of meteorites. Jupiter was so heavy that it held the asteroid belt in place. Without it, the asteroids would start flying towards us. Earth would feel a constant meteor shower. But there would be no one left on Earth to observe it anymore. Jupiter's explosion can be compared to a supernova. In fact, Jupiter is practically a star. If it were just a little bigger and heavier, it would start to shrink. The intense pressure on the planet's core would start thermonuclear reactions. Eventually, Jupiter will have turned into a brown dwarf, and it would be 50 times heavier than it is now. But because it doesn't have enough weight to do that, Jupiter is sometimes called a failed star. Well, maybe we should visit other gas planets in our solar system and try to light our match there. Saturn. Saturn's atmosphere is similar to Jupiter, but there's no oxygen for combustion there either. So all you have to do is admire the planet's beautiful rings and move on. Well, Uranus and Neptune are much smaller, and they don't have metallic hydrogen, so their explosion wouldn't be as strong. But you still wouldn't be able to ignite them with a match, because there's no atmosphere full of oxygen. But there is one planet where you could light a fire with your match. It's GJ1132b, and it's 39 light-years away. Scientists think it might have oxygen on it, although it's not a gas giant that has combustible gases in its atmosphere. But you can still sit on its rocky ground and make a fire to admire the unusual sunset.
Extremely hot and insanely fast. Yeah, that's me. Oh wait, you mean the space thing. Okay, first, they discovered Peg 51, an exoplanet that orbits a star similar to ours. An exoplanet is any planet outside of our solar system that orbits a star that's not the Sun. This planet was completely different from anything we've ever found. Almost the same diameter as Jupiter, but half the gas giant's mass. It took only 4 days for this exoplanet to orbit its star, which seemed impossible. It was definitely too fast for something so massive. And then, scientists started finding something they've named hot Jupiters all over space. Lots of heated gas giants were located only a couple of million miles away from their stars. Sometimes, there were a couple of space bodies orbiting their stars pretty closely, and many were a few times bigger than Earth. Solar systems where they found hot Jupiters are not like ours. We have a neat system with smaller rocky planets on the inside and big gas giants on the outside. And almost all of them peacefully orbit the Sun, following their trajectories. Everything is in order. When a star is at the earliest stage of its formation, it creates a disk of gases, debris, and dust surrounding it. It's called an accretion disk. These gases slowly get pulled into the star because of its gravitational forces, and this leads to some kind of a stellar whirlpool. The outer parts of the disk are more gas-dense than the center. With time, the whirlpool effect gets even stronger. The same thing happens with hot Jupiters, which causes these gas giants to start orbiting much faster than usual. This also carries it further toward the star in a tightening spiral. Luckily, our Jupiter didn't become a hot Jupiter. Our gas giant started its life as an icy Earth-sized asteroid, which is different from the way hot Jupiters form. During the time when it was forming, Jupiter was around 4 times as far from the Sun as it is today, somewhere between Uranus and Neptune. About 2 to 3 million years after Jupiter first formed in the accretion disk of our Sun, it started a 700 million year long phase astronomers call the Grand Tack. Now, tack is something a boat performs when going towards a buoy and then slipping past and around it. Then it speeds up and goes in the direction where it came from. That was the same thing Jupiter started doing, and in its tightening orbital migrations, the planet's gravity could have moved many asteroids and other space bodies, distorted the orbits of larger planets, and caused collisions and chaos. Jupiter's grand tack would have destroyed many big space bodies. It's a could-have-been scenario, but luckily, Jupiter changed its course and became a peaceful gas giant. Neptune, Uranus, and Saturn were starting their own version of this chaotic process. Saturn even got so big that its gravity started pulling Jupiter away from its orbit. But after some time, these gas giants' orbits became locked. Then both of them managed to clear away the gases remaining between them. And since these gases were some sort of fuel for the planet's migrations, Jupiter and Saturn could both finally settle into the stable orbits we know today. Jupiter can still lob 1 to 2 icy asteroids at the inner planets from time to time. But when our planet was younger, this could have been one of the processes that formed the oceans on Earth. But Jupiter is much calmer these days. Saturn's gravitational forces have moderated the situation and are now keeping it under control. Now, Jupiter is our protector. It's 2.5 times the mass of the other planets of our solar system combined. It's some sort of a gravitational shield orbiting around the inner part of the solar system. Jupiter redirects incoming debris and asteroids away from the inner planets, Mercury, Venus, Earth, and Mars, keeping us all safe. Because of this, Earth has always been protected, so our planet has had enough time to evolve complex life forms. And it hasn't been destroyed by asteroids, hot Jupiters, or other space bodies. Jupiter wasn't the only planet that could have collided with Earth. Scientists think Mercury might have been involved in a hit-and-run accident with our planet. Mercury is the innermost planet in our solar system. It's the closest to the Sun and the smallest planet out there. And it also keeps getting smaller. Nowadays, its diameter is around 9 miles smaller compared to its size 4 billion years ago. Scientists think this might be happening because the planet's core is made of iron, and this iron is cooling and becoming solid, which is slowly reducing the planet's size. Mercury is the planet with the biggest number of craters in our solar system. Its atmosphere is really thin, so it can do nothing to keep the planet protected from meteors. The largest crater on Mercury's surface is at least 963 miles across. It could fit Western Europe from Germany to Portugal. The object that formed such a crater must have been at least 62 miles long. With all these craters, Mercury looks similar to our Moon. It orbits the Sun faster than the other planets, so 1 year on Mercury lasts around 88 Earth days. That means celebrating a birthday every 3 months or even more often. At the same time, the planet rotates so slowly that a day on Mercury lasts almost 59 Earth days, a long time to wait to go to bed. There's a piece of Mercury on our planet. In 2012, a green meteorite was found at a street market in Morocco. Scientists studied its composition and concluded it could be from Mercury. Mercury doesn't have its own moons because of its small size and weak gravity. Plus, the planet is too close to the Sun. By the way, the only other planet without moons in our solar system is Venus. Mercury has a really thin crust, like a good pizza. One of the theories of the planet's formation claims there was a major collision where the planet lost most of its crust. It could have also moved Mercury from its original spot. It wouldn't be unusual. The gas giants in our solar system also didn't form in the location where they are today. Mercury also has an eccentric orbit, which means it could have been kicked out of its old orbit and moved to a new one. Scientists also think Mercury might have collided with the early Earth. One theory says that's how the Moon could be formed, out of all the material flying away after the big crash. There might even have been pieces of Mercury's crust in the mix. Exoplanets Kepler 107b and Kepler 107c are a pair of planets that orbit a star similar to our Sun in the Kepler 107 system. It's around 1,700 light-years away from us. These planets have almost identical sizes, both with a radius 1.5 times that of Earth. But one of them, Kepler 107c, is almost 3 times as dense as the other. That's because the planets have a different composition. Some scientists believe that Kepler 107b is less dense because it probably collided with another unknown planet in the past. This powerful hit took away part of its surface and left behind a very dense core rich in iron. A huge comet hit Neptune around 200 years ago, but since Neptune isn't a rocky planet with a thin atmosphere like Mars or Mercury, it's harder to find evidence of this impact. But a comet called Shoemaker-Levy 9 broke apart in 1994 and smashed into Jupiter. Astronomers managed to record this event. It helped them learn more about the elements and molecules the collisions left in Jupiter's atmosphere. This information helps scientists realize that the amount of carbon monoxide in the upper layers of Neptune's atmosphere is higher than in the lower ones. This means a big comet likely hit the planet in the past, since comets have carbon monoxide in their icy tails. Something huge slammed into Uranus, too, changing the planet forever. A space object twice bigger than Earth hit the ice giant. This left the planet tilted, and it looks as if it's rotating on its side. Uranus is extremely cold, way colder than it's supposed to be. It might mean that the object that slammed into it was probably a young protoplanet made up of ice and rocks. Also, some of the debris from that collision may have created a thin shell around Uranus. It still traps the heat coming from the core of the planet. There are strange energy pulses bombarding our entire galaxy, and they come from the other side of the universe. Over the last decade, scientists have been observing bizarre flashes of light coming toward our planet. This phenomenon is called fast radio bursts, or FRBs. These signals travel through a couple of billion light-years of dust and gas. That's a rather long way. So far, no one has figured out what's going on behind these bursts.
Check out that buff dude over there with the orange skin. He's been chilling on Mars for a hot minute, which is why he looks like he used the wrong shade of self-tan. You see, all those carotenoids in carrots, sweet potatoes, bell peppers, tomatoes, and pumpkins are protecting him from those UV rays. The more he eats, the more orange he gets. And as for his sturdiness, it's all about that Martian gravity. The gravity here makes us perceive our weight differently. And if you want to be a boss on Mars, you gotta eat heavily. Like, if a person weighs 150 pounds on Earth, it feels like no more than 55 pounds on Mars. So, overeating can help shorten that gravity-to-weight gap. Mercury is a whole different thing. It's hotter than Georgia asphalt during the day, but colder than Elsa's castle at night. You gotta be made of metal with a high melting point to be able to survive here. But for us regular humans, we'd be toast. Literally. Even though Mercury's the closest planet to the Sun, Venus is still the hottest one. Life on Venus, more like life on the Sun's evil twin. The temperature here typically hovers around 870 degrees Fahrenheit on average. Surviving at the boiling point of water, or in the extreme heat of Venus, is a challenge for most earthly species. Only a select few can endure boiling hot temperatures. Others rush to Starbucks to grab an iced latte with the first beams of the spring sun. So no human being can really evolve enough to survive on Venus. The only creatures that could thrive there are probably tardigrades and those weirdos who put hot sauce on everything. You wonder what tardigrades are? Well, those are minuscule and adorable caterpillar-like creatures that possess remarkable durability. They can endure boiling water, the depths of a sea trench, and the frigid, lightless void of space. Recently, tardigrades were included in a scientific study aboard a spacecraft that unfortunately crashed on the moon. Scientists speculate that the tardigrades may have survived the impact. Hey, would you like to turn into this creature and live on Venus? We're done with terrestrial planets. Let's move on to gas giants. Now look at this dude from Saturn. He's got flippers and not arms. He's got small holes with no external ear flaps instead of regular ears. Most of this gas giant is colder than your ex's heart, as the temperature is about minus 220 F. You can't walk on it, but you can turn into a snowball or an ice crystal if you're feeling frisky. Things are quite similar on Jupiter, so probably turning into a seal and chilling there is not that bad of an idea. At least you can live there rent-free. And don't even get me started on Neptune and Uranus. These guys are ice giants with no solid surface, so those sharp-clawed dudes you see in movies? Yeah, they don't exist. Plus, these two ain't exactly hospitable to life. I'll stick to my sweet potatoes on Mars. Thank you very much.
Wow, you're zipping through space in a large ship as big as 3 New York City Central Parks. There's a lot of commotion going on. No, it's not some alien invading the spaceship. It's a very important day. The date is January 22nd, 2700. You've just been born outside of the Earth's atmosphere. Happy birthday! There's a medical team attending to everything. Futuristic gadgets help out with every aspect. And the view from the giant spherical glass ship is nothing but the incredible vastness of space. You can't even see Earth anymore. The spaceship is flying to a new destination millions of miles away. ETA on reaching that new host planet? Decades. Fast forward a bit. You're 25 years old, and this spaceship's the only home you've ever known. So far. You've learned all the ins and outs of the ship. You start your day in your dorm, which has all the essentials: a small compact bathroom, a mini kitchen, a bunk bed, and a magnificent view of the stars and planet outside the ship's reinforced glass. And you never need to worry about space radiation. The ship has an everlasting magnetic shield that reflects space radiation, so it doesn't seep its way onto the ship. Otherwise, there'd be big problems. The ship was designed to have artificial gravity. Astronauts normally lose 1 to 2% of their bone density every month they're up in space, since they're just floating around all the time. But now, I mean in the future, in deep space travel, they're able to solve this problem. You make your way out of your dorm and see a wave of fellow crew members making their way to work. They're all gliding through on their advanced mini hoverboards, and everyone's wearing different colors, a space-age uniform. Yours is blue, so you hop on your board and join the blue wave. You get to the underpass of the space transport and begin your work. As an engineer on board, your job is super important, maintaining the ship and keeping it running. But something's wrong. Numbers are flashing all over the panels, and the dreaded red light won't stop blinking. You alert your coworkers, but they don't know what's happening either. Quick, you keep checking the logs and all the complicated equations, but nothing adds up. Panic starts to spread throughout the ship. The hair on your arms is standing on end. You try to click on as many buttons and switches as you can. The buzzing keeps getting louder and louder. The light is flashing brighter. Some of your colleagues make a break for it, and you're all alone in the red room. Suddenly, finally, your supervisor rushes down to help. After a while, the two of you figure it out. Whew, that was close. You still have a lot to learn about managing the ship. Since your early years, you were assigned to work as an engineer. You were great at physics, chemistry, math, all those sciencey things. It's just another day in the office. But on this ship, you may make captain one day. After work, you get a call from your friends wanting to hang out. And when I say call, I mean a phoneless device that lets you communicate with anyone while seeing all their info through a hologram projection that only you can see. You can also use it to listen to old tunes from Earth. Pop music has now become classical music, and movies are now 3D projections of your own imagination. You make your way out of the underpass and go up to the Space Plaza. That's where everyone hangs out when they have time off. Some cafes, restaurants, a barber shop, even an ice cream parlor. You've never hung out anywhere else. The space transport is essentially a small city which has all the important things society needs. That includes a biosphere full of animals and plants from different climates on Earth. Many tropical forests, many deserts, many rainforests, you name it. The biologists on board make sure to keep it all healthy so you feel like you're at home. Not that you've ever set foot on Earth. You enter the wild savanna and see some gazelles galloping around. A few wildebeest seem to be rummaging around, and a small pack of lions are on the prowl. In the jungle, you feel the humidity and the thick leaves and bushes all around. Some mountain gorillas are playing, and there are little tree frogs here and there. And lurking in the trees, making its way down for a sip of water, is a jaguar. Over in the dry desert, you see some roaming camels, a little rattlesnake slithering its way out of the heat, and some little scorpions crawling around in the sand. You learned a whole lot of biology these last 25 years. You know all about Earth, but you've never been there. Weird. After the tour of nature's habitats, you hear an announcement on the PA. It's the captain. The new planet is hours away, earlier than anticipated. Everyone assume positions for landing. Everyone on the ship rushes to their dormitories, except the key crew members needed to run the ship. You strap into your bunk bed that turns into a seat with fancy interstellar seatbelts. You look out your window and see a blue dot in the distance. It gets bigger and bigger, and it looks a whole lot like Earth, from far away at least. That didn't take all that long, only 25 years. Wonder what's going under the hood of that spaceship. You look back at your life in space, knowing this first part of it is coming to an end. It's kind of like living at the South Pole. At the bottom of the world lives a small community of scientists who work between winter and summer doing all kinds of research, from climate and geology to meteorology and astronomy. Their lives must be similar to living here in outer space. They have their own bunkers, scientific labs, and even recreational rooms for sports and music. The nature on the planet you're approaching is unlike anything on Earth. Tropical trees soaring higher than the highest skyscrapers. Oceans that are so wild, there are hurricanes that last for years, just roaming about. The pilot announces the landing. It's all good. Time to get to work. You unstrap yourself and head outside to see the new planet for yourself. Walking on land feels like, well, like arriving on a new planet. The humidity is thick and the wind is warm. The ship landed on the tropical side of the planet, where studies show is the best place to begin a brand new settlement. It's not going to be easy. Humans usually begin new settlements next to lakes and rivers. Think of the Mesopotamians, the ancient Egyptians, the Aztecs. The list is endless. They began as small settlements until they grew to be fully functioning mega-civilizations. By trading and exploring, they were able to advance their technology, learn new languages, and discover awesome cooking recipes. Hey, I could go for some pasta and sushi right about now. According to scientists, being born in space could alter the way humans look. Human heads could be bigger within thousands of generations. Who knows? There's no way to simulate it on Earth. We can even have different new skin colors, since we would need more melanin, that pigment stuff that protects us from sun radiation. Being closer to the sun or any hot burning mass of fire might mean we'd produce more or different kinds of melanin to protect us. We might turn dark brown, purple, gray, or even green. We'd have to wait a couple of million years to find out. And with no gravity, humans would have to get used to having a lower bone density, kind of like birds have. That means we'd probably be weaker than our old Earth human selves and have some slightly odd physical things going on. Gravity is essential for our balance, and mobility is one of the key factors for human survival. So, without gravity, we'd most likely have exoskeleton suits for walking and running, or taking out the trash. Now, nothing like this is going to happen for a very long time. They're still brainstorming how to bring someone into this world, or out of this world. Technically speaking, outer space is considered to be 62 miles above sea level from any continent on the world. Beyond that, endless possibilities. Well, let's go to Antarctica. Come on, you've got time. Remember to dress warm. Here we are, in the middle of endless snow-white plains and ice. The temperature in some places drops to a face-freezing minus 136 degrees Fahrenheit. It's so cold that if you throw hot water out of a mug, it will most likely land in the form of an icicle. But this cold is hot compared to the absolute zero definition. Scientists measure it on the Kelvin scale, where 0 is the lowest point. And that's why there is nothing colder than this temperature. All objects consist of atoms and molecules. When the temperature of any object rises, its molecules move quickly and chaotically, producing kinetic energy. If the temperature of an object drops, its molecules slow down in motion, and their energy decreases. So, absolute zero is when the particles stop altogether. There's no movement, which means it's impossible to make it colder. 0 Kelvin is equal to minus 459 degrees Fahrenheit, so that's like 3 times colder than in Antarctica. So, imagine that scientists created a vacuum room and filled it with gas at absolute zero. What happens if a human walks in there? I can't imagine that this turns out well, so let's send Bob in there. But don't worry, he's a crash test dummy. A little background first. When a hot object comes into contact with a cold one, its molecules exchange energy. Fast-moving particles transfer their energy to slower-moving ones and begin slowing down themselves. Then an equivalent exchange occurs and the temperature equalizes. But by default, the molecules move quite slowly until they're charged with energy. And at the same time, if you have a heated object, you will need more power to cool it. Yeah, it's a bit confusing. So let's go back to where the fun begins. Yes, if you go to absolute zero, you will freeze in seconds because all your molecules will start to slow down. But what will happen to the body? Well, let's follow the internal adventures of Crash Dummy Bob. First, its blood vessels narrow in the coldest places. The body distributes blood from frozen areas to vital organs like the liver, kidneys, heart, and brain. It's like emergency mode. The mannequin's body stores energy and blood for the most important, taking it away from less important areas. Then, a most dreadful thing begins. The body consists of billions of cells. When their molecules come into contact with a cold temperature, they slow down and freeze. Remember what happens to water in a frozen state? Remove the bottle from the freezer and let it defrost at room temperature. You'll see that the volume of liquid will decrease after a few hours, and when the water freezes, it increases in volume. And the human body is more than half made up of water. So, inside our mannequin, its cells get covered with sharp ice crystals that tear the internal structure of the cells. The muscles and blood vessels of the dummy are torn. Its skin gets a dark blue shade, and its blood freezes in its veins. A couple more seconds, and the dummy freezes completely. Absolute zero temperature stops all internal processes. Hey, Crash Dummy Bob said he wanted to chill, but this is ridiculous. Meanwhile, molecules are not only in living objects. Particles are everywhere, and absolute zero affects them too. The rays of light get the lowest energetic position. Photons slow down, and they can't move at the speed of light anymore. Okay, now it's time to finish the experiment. Something's going wrong, and the story becomes fantastic and hypothetical. Scientists can set molecules in motion, and the neighboring moving particles don't give them their energy. For some reason, the gas can't absorb the energy. Its frozen molecules slow down the others. The gas penetrates through the walls of the vacuum room and starts a chain reaction. The molecules freeze one by one. It's like they take a nap and charge all the matter around with this sleep. The gas area is expanding. Laboratory walls, doors, and windows are frozen. Scientists are covered with ice. Then the cloud goes outside the building. It's like a white spot that keeps growing and growing. The sun's rays get there, but can't move inside too fast. The zero envelops grasses, trees, roads, and cars. Scientists begin to sound the alarm as soon as a whole city gets inside the absolute zero clouds. The stopping of moving molecules occurs so fast that ice crystals don't have time to damage the skin and body in living bodies. It's not even freezing, but canceling existing life. Oxygen and carbon dioxide molecules are frozen. The air gets denser. Here a guy freezes in a jump and remains in the air. Here a frozen bird continues to hang in the air. Things inside the cold air are similar to a 3D picture. Everything froze in motion. It's like someone took a screenshot of a lifetime and printed it. And while the cloud of absolute zero continues to spread, scientists are rushing to solve the problem. The gas is growing and diverging in all directions. If it swallows the whole Earth, it will stop all the chemical processes on our planet. And without these processes, our home will become just another space rock, a lifeless piece of matter stuck in time. However, the real catastrophe will happen not when it envelops the entire surface of the globe, but when it reaches the core of our planet. This can lead to the release of energy that will destroy the planet. Perhaps the core may resist the absolute zero, but in any case, people are not going to wait for this to happen. The cold gas meets a volcano. Lava flows emit a deafening hiss and freezes. Black clouds of steam billow into the air. The cold cloud penetrates into the volcano. The collision of cold and hot temperatures releases energy. The volcano erupts and launches not fireballs, but sharp icicles of frozen magma. Meanwhile, heavy rains are beginning to fall all over the planet. When warm air collides with cold air, it moves away because it has less density. the liquid appears in the atmosphere and it forms clouds. Therefore, while the giant cloud freezes one part of the planet, rain clouds drench the other. And now scientists have finally come up with a solution. They've created a gas with an altered molecular structure that can stop 0 Kelvin temperature. So imagine you're heating water. The stronger the water molecules increase their kinetic energy, the hotter the water becomes. The molecules are moving faster and faster, but not all particles move equally fast. Some of them have medium and slow energy. Moreover, the low energy state of the molecules is more likely. This means that only a few particles move really fast in hot water. This distribution of low and high charge particles is called the Boltzmann distribution. The distribution is everywhere, both in hot and cold objects. If we look at any object at the molecular level, we'll see that there are many more slow-moving objects than fast-moving ones. So, scientists have come up with a solution. They create a gas that works in the opposite direction. It has more moving molecules inside this gas than slow ones. Scientists hope that this gas will wake the sleeping particles up in the absolute zero cloud. So, two gases collide with each other. The cold cloud can't freeze the reverse Boltzmann distribution cloud. There are too many active molecules. So, billions of active molecules charge the frozen ones with energy. All the molecules start moving and share the neighboring ones with their energy. Objects inside the gas cloud begin to wake up. People are slowly coming to their senses. As soon as the molecules come into minimal motion, they start to receive energy from the sun's rays. The particle movement is distributed equally between the two gas clouds, and life returns to normal. The molecular order has been restored. Right. And our little fable here comes to a happy, if not entirely credible, end. Bottom line here, don't worry. Scientists created absolute zero artificially, and it'll never happen naturally. There's no such temperature anywhere in the universe. Particle movement remains even in space's farthest and darkest corners with record low temperatures. The appearance of absolute zero is impossible because there will always be molecules around that move and share their energy with each other. Oh, by the way, no humans, animals, or Crash Dummy Bob were harmed in the making of this video. Are the lawyers happy? Okay.
Hey there, Brightsiders. My name is Tom, and today I welcome you to have a peek into the future. Let's imagine it's your birthday and the entire family is here to celebrate. It's a nice group of 562 people. Perfect. It takes a village to put down 1,000 candles. You cook that 40-layer cake and build that house yourself. With the new average life expectancy, you have enough time to master any hobby in the world. This is no sci-fi plot. There is someone in the world today who will live to be 1,000 years old. It could be your neighbor's granddaughter, your best friend, or even you. Thanks to better nutrition, easily available clean water, and a huge progress in medical science, people are already living much longer today than they used to 150 years ago. Now scientists are trying to figure out a way to slow down, halt, or even reverse the aging process. One of the leading experts on aging, Aubrey de Grey, is positive humans can medically defeat it. Aubrey had a successful career in IT, then he fell in love with biology and decided to solve the aging problem. So he went back to Cambridge to earn a PhD in biology and later invested most of his inheritance in his project. Almost all living beings age, but they do that at different speeds and in different ways. Quahog clams can live for over 500 years. A female mayfly has a full life cycle of less than 5 minutes. Scientists have already managed to extend lifespans of yeast, worms, fruit flies, and small mammals thanks to genetic manipulation and stem cell therapy. All living beings are made of the same chemical building blocks, so similar strategies could work for humans. Dr. DeGray explains aging as a result of metabolism going wrong. He discovered only 7 types of possible causes of it. If scientists can learn to settle that molecular and cellular damage before it gets too dangerous, they could prevent people from aging. Dr. DeGray believes that we'll be able to solve these problems in mice and stop their aging in 10 years with stem cell therapy. When it's done, scientists would need another 15 years to find similar solutions for humans. Stem cells provide new cells for the body as it grows and can replace lost or damaged cells and tissues that your body wouldn't manage to cope with naturally. It's possible because they can divide over and over and over again. Plus, stem cells have all the genetic information and can turn into any other type of cell. Adult stem cells are already used to treat some conditions. There are technologies that, in theory, can take and relocate strands of DNA and add or remove DNA. It would be as complicated as taking 850 volumes of Shakespeare and editing just one certain letter. Changing DNA in the future can help preventing aging and extend life. With every round of therapy, the patient would get healthier with younger organs, nerves, and bones. Dr. DeGray explains, humans of today will unlikely invent a therapy to make you live to 1,000. But scientists can give humans an extra 30 years. It would mean some extra time for new research. New therapies could be invented then and give humans another 50 years. This way, step by step, humans would stay ahead of aging, and someone living today can eventually celebrate their 1,000th birthday. The oldest officially confirmed age record for humans so far is 122 years. I sure hope my retirement plan would last that long. Don't want to be working at a fast food joint when I'm 370 years old. Well, anyway. Evolution has never stopped. Some scientists say it's been going up to 100 times faster over the past 10,000 years than ever before. The average body temperature has been going down with every decade for the past 200 years. In 1868, 98.6 degrees Fahrenheit was considered normal. Now, it's around 97.9 degrees. This happened thanks to progress in curing some infectious diseases that speeded up metabolism and made internal temperatures higher. It's also because people spend most of the time indoors with a nice cool climate now and don't need to make an effort to keep a natural body temperature. Over the last 150 years, the average height of an adult has grown by 4 inches. Humans also grew 14% heavier on average, some heavier than others. This became possible thanks to better nutrition, food, distribution, healthcare, and hygiene. Scientists are sure this trend will continue in the future. Taller and heavier people will need more calories, so this could be a problem. The genes are constantly changing too. Several thousand years ago, adults couldn't drink milk because a specific enzyme was turned off. When raising cattle became more popular, more and more people got the genes that control lactose tolerance. In India, a large group of vegetarians developed a mutation in one gene. It let them process certain fatty acids from non-meat sources and convert them into important nutrients for a healthy brain. People on a meat-based diet rarely have the gene. The bones are becoming weaker and less dense. This process started around 12,000 years ago along with farming. Diets and physical activity changed back then, and it made the human skeleton more fragile. This trend will likely go on as people are moving less and less these days. Some people who live in houseboats in Southeast Africa have developed larger spleens than their neighbors. This adaptation helps them stay underwater for a long time. They spend most of their lives fishing and collecting shellfish. In 100 years from now, people will get regular body upgrades even if they don't need them for medical reasons. Some companies already produce mechanical exoskeletons to make factory workers more productive. There are also exoskeletons for skiers to make them faster. With the technology of the future, there will be more robotic limbs. They will mimic or replace certain organs and will let people live out their dreams. You'll be able to climb Mount Everest at 80 with bionic organs controlled from your smartphone. Okay, you'll get new senses as well. Technology will let you feel the seismic activity through sensors on your feet, hear color waves through an antenna in the skull, predict weather through gadgets in your ears, and have other senses you can only dream of now. This could make humans closer to nature than ever. Or not. Humans will outsource more of their cognitive abilities to gadgets. Most people already can't read maps because gadgets just tell them where to go. There will be brain-machine interfaces, and you'll be able to transfer your thoughts online and analyze them. You already do something similar to your steps and your calories with apps that track them. New apps will let you track how much attention you pay to a certain problem or analyze an argument with your partner in detail. Hey, no need for people skills anymore, right? It's possible that scientists will find a way to increase the diameter of the neurons in the brain. That would give you an incredible reaction time, a real-life slow-motion function when you need to. With genetic engineering, more humans will look alike to fit the general idea of being attractive. There will be strong lines, straight noses, beautiful bright eyes, and all facial features fitting the golden ratio and perfect left and right symmetry. The brains will continue to grow, so there will probably be larger foreheads and maybe larger eyebrows to go with that. As it is highly likely humans will start living on other planets, we'd have to adapt to their harsh conditions. Lungs would have to be redesigned to gather more oxygen in new atmospheres. Tissues would have to change too to filter the dangerous elements of these different atmospheres. The further away humans will move from the sun, the dimmer it would be, and the larger the eyes and pupils would have to become. It would let them absorb more sunlight. They'd also develop new features like low-light vision and a sideways blink to help protect the eyes from cosmic rays. In 1,000 years from now, computers will become more and more human. To somehow compete with them, humans will become more integrated with robots. Tiny nanobots will swim around your body to boost all your natural abilities. Humans will be able to record sounds and have built-in phones in their ears along with super hearing. They will also have super eyesight and super health in general, which sounds quite nice actually. Merging human minds with computers will give everyone super brains. You'll be able to do the most complex equations instantly. Search the web and pull up any fact in your mind. You won't need to type any messages. You'll communicate with others through electrical signals and direct thought transmission. Humans will be an interplanetary species. Mars is the most likely new place of residence. New humans born on Mars will be taller than anyone on Earth. The Earth's gravity is 3 times stronger than that of Mars. Out there, the fluid between vertebrae would extend, making spines longer. Humans will most likely become immortal. To make it possible, scientists will have to figure out how to download consciousness into a machine. They are already trying to transfer consciousness between animals right now. Well, I can't speak for you, but for me, that's a bit of a nightmare. Hey, they can keep their nanobots. I'll just keep sitting here, watching the clouds go by and enjoying the sunshine. Like they say, it's not about the number of years in your life, but the life in your years, right?
We've all heard of the Sahara. Sure you have. It's the largest hot desert on the planet. A sea of sand covering an area larger than the contiguous United States. But have you ever wondered what lies beneath the sand dunes? To answer this question, we must travel deep into the past of our blue planet. Up until some 6,000 years ago, the Sahara was grassland. Humans were around at this time, not me, spreading agriculture around the planet. In the north of Africa, the color green dominated. Plenty of rainfall meant that there were lakes, rivers, pastures, and even forests. A completely different image of the Sahara from the barren landscape of today. But then, the climate started to shift. The region became parched, and the vegetation started disappearing. The wind did the rest. It took away the fine sediment after there were no plant roots to hold the ground together. Give it a couple thousands of years and you get a familiar image of the Sahara, sand and rocks stretching as far as the eye can see. But when it comes to volume, only a quarter of the Sahara is actually sand. The yellow sands of the Sahara are just one part of the story. The desert has many other features, such as gravel plains, salt flats, and plateaus. Makes you think if we understand the word desert correctly. For people who study such terrains, geologists, there is only one condition for defining a desert: precipitation. If an area gets little or no rain, then it's considered a desert. The Sahara certainly fits the bill. Its average annual rainfall is just 3 inches. Compare that to the nearly 45 inches a year in New York. When we look at precipitation, this sandy desert is only the third largest in the world. Number 1 and 2 are Antarctica and the Arctic. They are larger than the Sahara by millions of square miles. It sounds odd, but there is more than one type of desert. The first two are polar deserts, while the Sahara is a subtropical desert. But the difference in air temperature are staggering. In Antarctica's interior, temperatures plummet to minus 76 degrees Fahrenheit. Compare that to the highest temperature on record in the Sahara of 136 degrees Fahrenheit. But this desert has a cool side. At night, the temperature is roughly the same as the average yearly temperature in Denmark. This hot and cold roller coaster makes it hard to choose the right outfit when venturing into the Sahara. And what about the sand? How deep is it actually? The depth varies between 70 and 140 feet. That's not too deep. If you put the Statue of Liberty in a tall dune, half of it would still stick out of the sand. Its vast amounts in the Sahara were created by aeolian processes. That's Greek for wind. Over time, it blows and shapes the surface of the earth. In dry areas with sparse vegetation, winds erode the ground much faster. That's what happened in North Africa. Under all that sand is the bedrock and cracked clay. If you started digging, you would find the same everywhere on the planet, with one important difference. There is some type of soil covering the bedrock. This is not the case in the Sahara. Because of the arid climate and a lack of vegetation, sand covers the ground below. Over the course of thousands of years, a lot of interesting finds ended up in the desert sand. For example, there are petrified tree trunks. These are essentially preserved prehistoric trees. They date back to the time when the region was lush green. In some places, the trees of this fossilized forest are at least 65 feet tall. The wood is so well preserved that you can still see the texture and knots. There are even fossilized pine cones. In 1992, scientists found glass fragments in eastern Sahara. These canary yellow glass shards were scattered across hundreds of miles. They didn't belong to an ancient civilization, although ancient Egyptians used them to make jewelry. In fact, the breastplate of King Tut had a beautiful scarab beetle centerpiece made from this desert glass. For a long time, scientists were puzzled about the true origins of these fragments. They finally concluded that the glass was around 29 million years old. It is an impact tape. If that sounds like it has something to do with the word impact, you are correct. These rocks are formed when a meteorite hits the surface of the Earth. This generates a lot of heat. Scientists estimate that the temperature needed to melt this mineral was close to 3,000 degrees Fahrenheit. Apart from the regular fine-grained sand, we also have melted sand in the Sahara. But the desert conceals other unlikely artifacts. Shark teeth are a common find in Morocco, which sits in the western part of the Sahara. What are the fossilized teeth of these marine predators doing in the middle of the desert? This part of the world looked entirely different millions of years ago. There was a sea cutting right through what is now a desert. The Trans-Saharan Seaway ran the length of present-day Algeria and Mali. It was around 165 feet deep. That was enough for all sorts of aquatic animals to inhabit it. Large catfish, sea snakes, and of course sharks lived in the area. British archaeologists even unearthed a turtle shell in Mali in the 1980s. For centuries, there was even an entire city hidden under the desert. Timgad was a Roman outpost constructed by the Emperor Trajan around the year 100 in the current era. For various reasons, its residents abandoned it around the year 700. The sands of the Sahara soon engulfed the city. It had remained hidden for nearly 1,000 years. Then, in the 1700s, a Scottish explorer started digging out the city. His team first uncovered a sandstone triumphal arch 40 feet high, similar to the ones we can see in Rome and Paris today. An amphitheater soon popped out of the sand, and it was followed by well-preserved statues of Roman emperors. The Scotsman's find was so impressive that no one believed him at first. It took 2 more centuries for archaeologists to fully excavate the city during the 1950s. The site covers a surface as large as 10 polo fields. The ruins reveal the full mastery of Roman city planning. All the streets meet at a right angle in what is known as an orthogonal grid. You can find the same layout in modern cities such as New York. Historians estimate that during its heyday, 10,000 people called Timgad home. Different nationalities lived here, from Romans to people of African descent. Today, more than 2.5 million people live in and around the Sahara. They are spread across 11 countries in total, and their living space is growing. The desert is 10% larger than it was just a century ago. This process doesn't involve sand pouring out of the Sahara. The ecosystems on the edges of the desert simply change over time. The wind blows the soil away and vegetation dwindles. The perfect conditions for the formation of a desert landscape. These changes are happening in the Sahel, a region south of the Sahara Desert. That's why the African countries have recently come together for a project called the Great Green Wall. The primary goal is to stop the desertification of the Sahel and hold back the sands of the Sahara. Their plan is ambitious and involves planting a wall of trees from the west to the east of the African continent. The proposed forest is not only going to be long, but wide as well. The Sahara and the Sahel share a historic bond. Since antiquity, camel caravans have been making the journey from Africa's Mediterranean coast in the north to the savannas in the south. The golden age of this trade kicked off in the 9th century. The perilous journey took several months to complete. The route was 2.5 times longer than the length of the Grand Canyon. Explorers still find evidence of these ancient caravans hidden away under the sands of the Sahara. Under the burning sun, among the sand dunes, somewhere in the Sahara Desert, you're walking in search of an ancient treasure. Finally, you find a strange rock in the sand. It's big, looks like a large piece of black coal or rock, but something shiny on its surface makes the rock unusual. This unique find is the oldest thing that has ever been discovered on our planet. This rock was born long before Earth appeared in outer space. The unusual meteorite was found in 2020 in a remote area of the Sahara Desert. Scientists have analyzed the isotopes of magnesium and aluminum on the stone's surface and found that its age is about 4.5 billion years. At the moment, this is the oldest sample of magma from space in history. It belongs to a small protoplanet that didn't have time to form completely. It happened a very long time ago when our solar system was forming. Many huge asteroids were floating in space. Some of them were formed into huge celestial bodies, which later became planets. The big rocky planets were absorbing the smaller ones. The rock was part of a little protoplanet that just began its formation, but another huge asteroid destroyed it. The planet shattered into billions of pieces. Some of them became part of other planets. Some flew outside the solar system, and one piece that had been wandering in space until our Earth was formed. After that, it hit the planet's atmosphere and fell into the territory now known as the Sahara Desert. The rock was discovered in 2020, but the erosion of extraterrestrial rocks shows that it could have fallen much earlier. This ancient thing weighing around 70 pounds has several pieces of different meteorites inside. In simple words, it's a volcanic rock consisting of lava. It has cooled, solidified, and crystallized. That's why you notice the glitter. Scientists hope that further study of the rock will help to learn more about our solar system foundation. The biggest asteroid discovered in the U.S. is the Willamette. Its size is 84 square feet, and its weight is more than 15 tons. This is half the weight of a bus. Several people can fit on the surface of this outer space object. But the coolest thing is that it's not a rock like most meteorites that were found. Willamette is made of nickel and iron. This massive piece of metal was discovered in 1906. Now, the huge rock is kept at the American Museum of Natural History. The largest meteorite ever found is Hoba. It's located in Namibia, and people have never changed its position because it's too heavy. The weight of Hoba is 60 tons. It's heavier than a tank. The next space-related event occurred on February 28 in southwest England. On this day, a huge flash lit up the sky. Then there was a loud crash. Several residents opened the doors of their houses and noticed a black sooty spot on the lawn. They immediately guessed what had happened and reported the discovery to the British Meteorite Observation Network. If you ever find a meteorite, report it to some geological research or space center as soon as possible. The longer a space rock lies on the ground, the faster it loses its value. Rain, dust, snow, wind, scorching sun, all these factors damage the surface of the meteorite. It makes it difficult to study the celestial object. The meteorite found in England looks like coal, but it's way softer and more fragile. It most likely used to contain frozen water. The rock is part of a huge asteroid that plowed through outer space when our solar system hadn't fully formed yet. They found a unique combination of minerals inside the rock. It can help scientists learn more about the origins of the solar system and life on Earth. Now we're heading to Germany, to the small town of Nördlingen. A huge ancient meteorite's hidden here. It's very difficult to notice it unless you know the secret of this town. You're walking along the cozy little streets and looking at the buildings with beautiful architecture. You spend the whole day there and don't find anything that reminds you of a meteorite. To solve the mystery, you need to get out of town. So you climb a high hill and see that the city is located inside a pit. For a long time, locals were sure the house was located in the crater of an extinct volcano. If you look at the houses from a certain angle, you may notice an unusual shining coming from them. In the middle of the 20th century, a group of geologists came here and immediately declared that the crater doesn't look like a volcanic one. The town was built on a huge crater left by a meteorite. The huge celestial body fell here about 15 million years ago. It was so hot that the carbon bubbles inside instantly turned into small diamonds. When people were building this city, they didn't know they were using expensive stones, since the diamonds were hardly visible. The locals never attached importance to the fact that the city walls shine unusually in the sun. Now they believe this place was built from diamonds that had fallen from the sky. Our next stop is in the UK again. This time the rocks are of an earthly origin. The famous Stonehenge. People place circles of rocks here in a certain order. Everyone knows about this archaeological monument, but no one knows the reason for its creation for certain. Another construction built out of mysterious rocks was discovered just 2 miles away. It's called Superhenge. It's bigger, heavier, and takes up more space. Each plate here is 15 feet, which is about the height of 2 floors. Once, the stone stood vertically and formed a huge semicircle. But someone pushed the stones over about 4,500 years ago. It was a college prank. No, not really. That's why they couldn't be detected for a long time. Scientists still can't solve the mystery of Superhenge, but they believe the standing vertical stones were part of some huge monument. Some other amazing rocks are located in the south of Costa Rica. There are big ones, the size of a human, and there are smaller ones, the size of bowling balls. And they all have a perfectly round shape. These giant rocky spheres were created by people. It must have taken years of polishing using stone tools to get the perfect round shape. These balls are incredibly heavy, but can easily roll like a basketball. All the rocks are of a different age. Some of them were created about 2,500 years ago. Most of them are made of molten volcanic magma. Until now, scientists don't know for what purpose these stones were used. They were found in different parts of Costa Rica, near big cities. It's possible that ancient civilizations installed them specifically to show the greatness of local kings. Also, many experts believe the rocks were used as a tool for studying astronomy. The people who knew their purpose of the rocks had disappeared, and the history of the stones was lost along with them. Let's finish our journey with the coolest archaeological find. You're walking through the desert of Peru and climbing a low hill. You look down and notice the surface of the hill is covered with strange lines. You walk far away and see a huge cat on the hill. Such a drawing is called a geoglyph. Its length is around 120 feet, which is about half the size of a Boeing commercial jet. Archaeologists discovered the giant cat in 2020 and found out that it had been created somewhere between 200 and 100 BCE. This huge drawing is part of a mysterious group of different pictures. In addition to the cat, there are other animals, plants, and fantastic figures. All of them were found in the desert of Peru. The kitten was found by chance. Archaeologists didn't see it at first because natural erosion on the hillside had almost erased the silhouette. There are many myths around arguably the greatest structure ever built by humans, the Great Wall of China. Some say it's so grand that it's visible from space. Others claim that you can see it from as far as the moon. Other theories suggest that the builders of the wall were left inside. Well, sorry to disappoint you, but all these impressive stories are just myths. But even with those stories busted, the Great Wall of China is an impressive and truly breathtaking structure. So let me tell you its true story. Today, China is one of the most populated countries in the world, counting as many as 1.4 billion residents. It's also one of the oldest nations in the world. It has 3,500 years of continuous written history, but the civilization existed long before that. There is a theory that while the European continent, for example, was most likely reached by humans from Africa, China wasn't populated by settlers that came from somewhere else. Some people believe that the Chinese civilization got formed from local Stone Age people who lived on the territory since the prehistoric period. So now, the Great Wall of China. It's truly big even by today's standard, stretching for over 13,000 miles. To imagine it better, it's almost 5 times the distance between New York and Los Angeles. Or even a bit greater than the distance between the North and South Poles. Even in modern times, people have never built anything close to this big. Of course, it didn't take a day to build the Great Wall of China. 2? Keep going. In fact, the wall was being built for centuries. Maybe you know that ancient cities had walls around them to protect themselves from invaders. Yes, Chinese cities had them too. The first Chinese emperor united the country in 220 BCE and got a brilliant but very ambitious idea to turn all city walls into one big wall that would defend the country's border against attacks from the north. A trusted general directed the construction, enrolling a big group of workers, soldiers, commoners, and convicts. Back then, the wall was built of rammed earth and wood. In some places that were strategically important, the sections of the wall overlapped to provide maximum security. The walls were around 26 feet high on average. But the Great Wall didn't yet look like the construction we know today. Every next emperor would pick up the big wall project, strengthening and extending it, repairing, but also modernizing construction techniques. Some used bricks to build it. Others moved on to granite and marble blocks. Watchtowers and platforms weren't there from the beginning as well. They were added by Ming emperors. The watchtowers made it possible to communicate with other parts of the wall through smoke and fire messages. So, the wall is quite inconsistent in terms of material, but it only adds more charm to the construction and shows how much effort and time it took. The reasons why some parts of the wall have been standing for centuries and are still in good condition is glutinous rice flour. Turns out, this sticky rice mortar is almost like cement. It's very strong and waterproof, sealing the bricks so tightly together that even sneaky weeds can't grow between them. You may also notice that some bricks have writings carved on them. They were left by the workers who were building the wall. The purpose of those writings is quality assurance. They contain such information as location, quantity, and responsible officials. So, in the case of some problems with the quality of materials or constructions, it would be known who should be held accountable for it. Recently, a research group has looked through official historical documents of the Ming Dynasty that ruled China from the 14th to the 17th centuries. They came across records of secret doors in the Great Wall, so they decided to find them. They used a flying robot to capture continuous centimeter resolution photos of the wall. They photographed 90% of the wall that was built during the Ming Dynasty and discovered the remains of over 220 secret doors along the wall. Some of them have a specific width and height that allows only one person to go through. Others are large enough to allow 2 horses to pass at the same time. Why are the doors there? Well, the Great Wall's main goal was to protect the country from the enemy. Building doors that could let the enemy in would undermine the whole point of having a wall. So, of course, the doors were secret passages. They perfectly matched the surroundings topographically, and the exit on the outside was camouflaged with bricks so that it was almost completely indistinguishable from the brick wall. The wall was never just a defensive wall, and it was never completely closed. It could be opened on demand. It was also a structure used for trade and commerce, communication between inside and outside the wall, and of course, for defense and spying. Some doors were used for trade with the other side. Through smaller doors, a person would sneak out to spy on the enemy that lived on the other side. The hidden gates were also useful for a sudden attack. As you remember, some gates were camouflaged with brick on the outside. The exit was so indistinguishable that the enemy had no idea exactly where it was located. The inside entrance for Chinese soldiers was hollow, so they could walk through the wall and break the camouflaged exit gate from the inside, starting their surprise attack. Now, even though the main point was to prevent outsiders from getting into the city, the wall wasn't too effective on that matter. It could still be climbed over or marched around. So the wall was being watched at all times, and the guards gave signals to the troops if they saw the enemy approach. Also, the wall provided more time to mobilize and bulk up the country's forces or lure the enemy troops into a difficult strategic position. The construction stopped at the end of the 19th century. The wall lost its strategic and military importance due to technological advances. Over the centuries to today, only 8% of the Great Wall is in good condition, and the rest is damaged. Also, around 1/3 of the wall has disappeared without a trace, due to both natural erosion and human damage. I guess you could say it's now just a pretty good wall. As you remember, the first parts of the wall were built out of rammed earth and wood. These are not the most unfailing materials if we're talking about thousands of years. Also, destructive farming methods have turned large areas into a desert and contributed to erosion. Also, many bricks were taken away from the wall in the last century to be used in building farms and houses. The wall is being deconstructed stone by stone even today, but this time by tourists. Quite a few of them take a stone as a souvenir. That's a total of a lot of stones, considering that over 10 million tourists visit the Great Wall every year. Since 1987, the wall has been a UNESCO World Heritage Site, highlighting that it has an outstanding importance to humanity. The wall is one of China's 56 World Heritage Sites, second place among countries with landmarks protected by UNESCO. Who's first, you ask? Well, the top spot, with 58 World Heritage Sites, belongs to Italy. And do you know that the wall isn't only a famous tourist attraction, but also the location of the Great Wall Marathon? It's a marathon that was established in 1999 and is one of the most challenging ones in the world. You guessed right, people run along the wall, including all the steps. There are 3 distances, so that participants can run a full marathon that is 26 miles, a half marathon that's 13 miles, or just have a fun run of 5 miles.
It was the beginning of the 20th century, and 2 rivals, Robert Scott and Roald Amundsen, set on their expeditions to become the first people in history to reach the South Pole. The race wasn't easy, and it ended tragically for Scott. Amundsen has won and set his tent on the pole before his rivals. A member of Scott's expedition known as Terra Nova, British geologist Thomas Griffith Taylor, not only survived the harsh conditions but also made an unexpected discovery. He found a waterfall of what appeared to be blood at the rocky base of the glacier, which now has his name, in 1911. It took scientists more than a century to figure out what is behind the eerie coloring. A team of American scientists journeyed to Taylor Glacier with powerful electron microscopes to analyze its contents. Previous studies had scratched the surface of the Crimson Enigma, but no one had previously done a full-scale analysis of its mineralogical makeup. These researchers unleashed a whole arsenal of analytical equipment and spotted little iron-rich nanospheres. These teeny-tiny particles, 1/100th the size of human red blood cells, originate from ancient microbes. They flourish abundantly in the meltwaters of Taylor Glacier. These nanospheres are jam-packed with iron, silicon, calcium, aluminum, and sodium, forming a unique composition that paints the subglacial water a vivid shade of red. These nanospheres don't have the usual crystalline structure found in minerals, which is why previous detection methods failed to spot them. Taylor Glacier's icy depths harbor an ancient microbial community that has thrived in isolation for thousands or possibly even millions of years. This discovery could help us in the search for life outside of Earth. Dr. Ken Levy, a research scientist at Johns Hopkins University, has some impressive expertise in planetary materials and the analysis of Martian samples. He decided to find out what would happen if a Mars rover landed in Antarctica. Could it figure out what makes bloodfalls so mesmerizingly red? So, researchers treated bloodfalls as a simulated Martian landing site. They used techniques inspired by the rovers exploring the red planet. The samples they collected were sent to Johns Hopkins processing facilities. There, Livy unleashed the power of transmission electron microscopy and revealed the enigmatic nanospheres. He made the conclusion that our current methods of analyzing other planets' surfaces with rovers fall short. They can't unravel the true nature of environmental materials, especially on chilly planets like Mars. These materials might be super tiny and non-crystalline, throwing off our detection methods. To truly grasp the essence of rocky planets, we'll need transmission electron microscopes. Strapping one onto a Mars rover isn't feasible yet, but it could mean a start of a new era in space exploration. Have you ever seen a waterfall on fire? Every February, when the stars align just right, Horsetail Fall in Yosemite National Park gets a sensational makeover. As the sun sets, its rays hit the waterfall at the perfect angle, transforming it into a blazing display of vibrant orange and red hues. We don't know exactly who and when discovered this natural miracle. The original valley dwellers may have known about it, but they kept it to themselves. It wasn't until 1973 that photographer Galen Rowell captured the first known photo of the waterfall, bringing it into the limelight. Since then, the firefall has become a global sensation, spreading like wildfire on social media and drawing crowds from far and wide. This magnificent cascade draws hundreds of spectators every year, but they can only see the show under certain conditions. First things first, Horsetail Fall needs a flowing stream. If there's not enough snowpack in February, the waterfall won't have enough water to create the magic. The temperatures must be warm enough to melt the snowpack during the day. If it's too chilly, the snow will stay frozen, and the fiery spectacle won't ignite. Second, we need a clear western sky at sunset. Those sunbeams need a straight path to hit Horsetail Fall and make it come alive. And since the weather in Yosemite is ever-changing, clouds can magically clear up just in time for the show. If all the conditions are just right, you'll witness the Yosemite firefall in all its glory for about 10 minutes. The mystery of the sailing stones in California's Death Valley National Park has puzzled scientists for years. Heavy stones seem to have a mind of their own and move across Racetrack Playa, a dried-up lake bed. They leave behind a trail on the cracked mud. There were all kinds of theories to explain this phenomenon, from magnetic fields or dust devils, which are strong whirlwinds, to mischievous pranksters. No one has actually witnessed these rocks in action, which only added to the mystery. In 2006, a NASA scientist named Ralph Lorenz entered the scene. He was studying weather conditions on other planets, but he couldn't resist the allure of Death Valley and those elusive sailing stones. He had an eureka moment while tinkering at his kitchen table with a Tupperware container. Lorenz filled the container with water, leaving a small rock poking out, and chucked it in the freezer. Then he placed this icy construction in a big tray of water with sand at the bottom and gently blew on it. The rock began to glide across the water, leaving a trail in the sand. Lorenz had been studying how ice can make big rocks float and move along tidal beaches in the Arctic Sea. Applying this knowledge, he and his research team figured out that, under certain winter conditions in Death Valley, enough water and ice could form to make the rocks float across Racetrack Playa in a light breeze. And as they glided, they left their mark in the muddy terrain. The River of Five Colors, Cano Cristales in Colombia, has the unofficial title of the most beautiful river in the world. For most of the year, it looks like any other regular river. The real magic happens between the wet and dry seasons, when the water level is just perfect. This unique river floor is lined with a special plant, and when the conditions are right, it bursts into a dazzling display of colors. Think vibrant reds, stunning yellows, and lush greens, all mingling with the blue water. It's like stepping into a living rainbow with 1,000 shades in between. This phenomenal display only lasts for a few weeks, from September through November. During Colombia's wet season, the river flows too fast and deep, covering up the river floor and denying the plant the sunlight it needs to turn red. And in the dry season, there's simply not enough water to support the vibrant life in the river. So you have to catch it at just the right time. The reason behind Maldivian beaches glowing in the dark at night isn't a mystery, but it doesn't make them any less impressive. It happens thanks to the bioluminescent plankton. These tiny creatures are like little underwater disco balls, emitting a cool blue glow when they are agitated or on the move. Imagine walking along the shoreline and leaving behind glowing footprints. You can even take a night swim amongst these magical plankton. Researchers have discovered that their bioluminescence is actually a clever defense mechanism against predators. When these microorganisms flash their little blue lights, it disorients and surprises their attackers. The plankton produces this light using a chemical called luciferin. These enchanting plankton can appear at any time of the year. The best chances of seeing them in all their glowing glory are from June to December. During this period, there's a higher volume of plankton in the seas of the Maldives, creating the perfect conditions for a luminous show after the sun sets and the night sky takes over. You'll only witness the magic of bioluminescent plankton when tidal currents bring them close to the shore in large numbers. It's hard to predict exactly when this spectacular show will happen, so make sure to do your research and prepare to take photos with a high ISO to capture it, exactly like it looks in travel catalogs.
You wake up with a start, open your eyes and look around. Oh, you're inside your sleeping capsule. Its walls are littered with different buttons and tiny screens. You press one of them, and one of the sliding panels sweeps to the side. You crawl out of your pod and start another regular day on the moon. Or maybe you open your eyes and come up to the window to have a look at the weather outside. Everything seems to be as usual: blue trees, purple sky, and low-hanging yellowish clouds. Great, you won't need your acid rain protection today. Or maybe you'll open your eyes to the dry plains of the Red Planet. You'll eat your 3D printed breakfast and set off on a trip to Olympus Mons, the largest volcano on Mars. You've been planning this climb for ages. Whatever scenario it is, one thing is glaringly clear: you're not living on Earth. Why? There might be a few reasons why people could have abandoned our beautiful green paradise. The sun might have grown too old and started to expand, burning vegetation, boiling the oceans, and leaving Earth uninhabitable. Or it was probably a collision with the Andromeda Galaxy. Yes, the one that is bound to crash into the Milky Way in about 4.5 billion years. It could have been a wandering asteroid, large enough to destroy all kinds of life on our planet. Of course, these days, astronomers have their own ways of spotting such space intruders. But what if their equipment malfunctioned? It would end badly for Earth and Earthlings. A much sadder reason for us to leave our beloved planet would be our own actions and the risks we pose to it. According to statistics, these days, the onslaught of droughts, earthquakes, floods, and epic storms is triple the number from the 1980s and almost 54 times that of 1901. Climate change could lead to water shortages, a severe lack of food, and the submersion of coastal regions. If it all went too far, we'd have to conserve the planet to save at least some of its flora and fauna. Then, it would become a nature reserve the remaining people would sometimes visit. But if not on Earth, where would humanity live? Surprisingly, there are quite a few options. For example, we could dig several feet beneath the surface of the moon and build our bases there. Or the first towns on the moon might be built in craters and covered with protective materials, like plastic reinforced with a net made of titanium and UV-resistant superfiber. The inhabitants would have to access their homes through airlock entrances dug into a mound. Or we could skip the moon altogether and set off towards the moons of Jupiter, Saturn, Uranus, or Neptune. Yes, they're much farther from the sun and probably way too cold for us. But on the bright side, these moons are believed to contain vast amounts of water, carbon, and nitrogen. And still, the most likely destination is Mars. Unlike the moon, which has a very, very weak atmosphere that consists of unusual gases, Mars has a bit denser atmosphere, even though it's still about 100 times less dense than the atmosphere of our home planet. In any case, it can offer us some protection against harmful space radiation. Mars also has about 40% of Earth's gravity, which is not that bad. We could probably get used to it with time. Plus, there's water ice on the red planet. The soil there contains enough carbon to grow plants. With time, the planet could be terraformed with the help of water from underground ice or imported from an ice asteroid. We'd use this water to form a thin ocean and maybe even create a breathable atmosphere. Or we could find an exoplanet that has all the resources to support life. An exoplanet is a planet outside our solar system. It would probably be much easier for us to find a world that would be perfect for us, rather than reconstruct the already existing world with its own workings.
Imagine traveling 10,000 years into the future. What would our planet look like? Would there be giant volcanoes? Would most of its surface be covered with oceans? And what if we traveled even farther, 1 billion years in the future? Now, Earth is about 4.5 billion years old, and when it formed, it looked very different from now. It was an extremely hot world, drowning in molten magma. Then, over the course of a few 100 million years, the planet began to cool. That's when the oceans filled with liquid water appeared on its surface. Heavy elements, initially floating on the surface of this bizarre Earth, started sinking past the oceans and magma toward the center of the planet. Earth became layered. The outermost layer was a solid covering made out of relatively light material, while the denser substances sank to the center of the planet. That's how it all began. Now, speaking about such a distant future, and 1 billion years is no joke, the chances that humans will still be around are very slim. You see, there are quite a lot of threats the human race might face in the process of its development. Climate change, overpopulation, falling asteroids and comets, ice ages, the sun getting hotter. Let's say you've got your hands on a time machine, and on your way to see what our planet will look like in 1 billion of years, you make a few stops. And the first one is 10,000 years into the future. One of the main changes is the appearance of people. Apparently, genetic differences are no longer regional. Such traits as skin tone or hair and eye color are evenly distributed around the globe. 20,000 into the future, and you don't understand people anymore. None of the current languages is recognizable, and the language people speak only has 1% of the present-day vocabulary. Moving further, 50,000 years into the future, and you realize with horror that a new ice age has started. Niagara Falls have eroded, and a day on Earth has increased by 1 second. Your next stop is 250,000 years from now. The landscape of the planet has changed a bit. For example, a new island has formed in Hawaii. After exiting your time machine 500,000 years into the future, you realize you might have made a mistake. Fires are raging all over the planet and the air is nearly unbreathable. The reason is a giant asteroid. People didn't manage to prevent it from hitting Earth. You hop into your time machine and set the timer to 1 million years from now. It seems you're out of luck. This time, it's a massive supervolcano eruption, spewing out hundreds of cubic miles of ash. It's already produced enough lava to fill 75% of the Grand Canyon. 2 million years into the future, and people have created settlements all over the solar system. Humans look different on different planets and moons since their bodies have adapted to particular conditions existing in those regions. 50 million years into the future, and you see that Earth is still changing. A massive part of Eastern Africa has broken off, forming a new ocean basin. Africa has crashed into Eurasia and closed off the Mediterranean Sea. A new mountain range, higher than Mount Everest, has formed between these two landmasses. Also, Mars has collided with its moon and got a cool ring system, just like Saturn. You make a stop 600 million years into the future and find out that a gamma-ray burst has occurred around 6,500 light-years away from Earth. Luckily, it hasn't hit our planet. Otherwise, there would no longer be the protective ozone layer and it would have caused a mass extinction. Also, the moon is now so far from Earth that there are no more total solar eclipses. And now, your final destination, Earth 1 billion years from now. With bated breath, you leave your time machine and freeze in shock. Our once beautiful planet has turned into a lifeless desert. The levels of carbon dioxide have dropped dramatically, and there's no photosynthesis anymore. It means that free oxygen and ozone have disappeared from the atmosphere, and there's no more complex life on the planet. Plus, the sun's luminosity has increased by 10%, making average temperatures on Earth rise at least twice. You feel as if you're standing in a giant damp greenhouse. The oceans have evaporated, leaving a few small pockets of water at the poles. What about people? You won't find them on Earth. By now, they have already colonized some faraway planets in faraway galaxies. You should probably leave this inhospitable world too.
Our channel has new space-themed videos every day. Let's check how closely you watch them. All the answers to these questions have already been voiced in our videos. Let's go. Level 1. Asteroids are small planets. False. Asteroids are small celestial bodies that are not planets. Saturn is the only planet in the solar system that has rings. False. Saturn has rings, but other planets in the solar system also have rings, such as Jupiter, Uranus, and Neptune. The closest planet to the Sun, Mercury, is the hottest planet in the solar system. False. The hottest planet in the solar system is Venus. Its temperature reaches 462 degrees Celsius. The Sun is yellow. False. It is actually white in color. It appears yellow from Earth because of light scattering. All stars emit light. True. All stars emit light. Too easy. Level 2. All comets have tails. False. Only comets that come close enough to the Sun have tails. Comet tails are made up of dust and gas that are heated and vaporized by sunlight. Space is always cold. False. In space, temperatures can vary widely, from very low temperatures in interstellar space to very high temperatures in the neighborhoods of stars. There is a magnetic field in space. Truth. There's a magnetic field in space. There are black holes in space that spin faster than light. False. As we know, nothing can move faster than light. Gravity is the only force that acts in space. False. There are other forces at work in space, such as the electromagnetic force and nuclear forces. Level 3. There are stars that are colder than the human body. True. Brown dwarfs belonging to spectral class Y are the coldest known star-like objects. Some of them can have temperatures around 25 degrees Celsius. If Saturn were placed in water, it would float on the surface. True. Saturn's density is lower than that of water. The phases of the moon are created by the Earth's shadow. False. The phases of the moon are caused by the motion of the moon around the Earth relative to the sun. When the moon orbits the Earth, to an Earth observer, some parts of its surface are illuminated and others are in shadow. More than 100,000 meteorites fall to Earth every day. False. According to the American Meteor Society, between 10 and 50 meteorites fall to Earth every day. All planets in the solar system have natural satellites. False. Mercury and Venus are the only planets in the solar system that do not have satellites. How many questions did you answer correctly? Write about it in the comments. And until the next videos.
Jill and Jim live in the US. One day, Jim goes on a business trip to Europe. Jill misses him very much, so she calls him up. She asks Jim to take a selfie and send it to her. He agrees. Jill gets furious as soon as she sees the picture. Jill: "You're a liar." How did Jill figure it out? Europe and the US are in different time zones, but in Jim's photo, it's noon. That's American time. He never left the country. Can you find a zombie in this picture? Over here. What about this ski resort? Can you spot any zombies? Hello? And now let's see if you can find a zombie in this amusement park. It's hiding over here. The biggest bank in town was robbed last night. The local police investigate this case and find 2 suspects. They go to search their houses. The officer sees a clue and figures out who the criminal is. How did he guess? Let's take a look at the walls. There's the same picture in both houses. But this one is hanging upside down. There's probably a stash behind it. Busted. A teacher has 21 colored pencils. 7 red, 7 yellow, and 7 blue. She needs to divide them into 2 piles so that one pile would have 3 times fewer red pencils than the second one. And the second pile should have 2 times fewer yellow pencils compared to the first pile. How many blue pens would be in each pile? Zero. The teacher had 21 pencils, not pens. Can you rearrange these crayons and make 4 triangles? To solve this mystery, you gotta think outside the box. Here's the correct answer. Let's make the task a little harder. Can you remove just 2 crayons to make 2 squares? Ready to see the result? There you go. Donna goes to a supermarket and spots something weird. 2 of these women are pregnant, but one of them just stole a watermelon. Can you guess who? It's the third lady. She's wearing high heels, not what pregnant women would wear to a grocery store. Kitty wakes up in a creepy basement. She needs to open this door to escape. Can you guess the right order to press the buttons? Kitty needs to make the word unlock from the first letters of each emoji. Therefore, she should press the buttons in the following order: unicorn, nose, lobster, onion, cactus, kiss, and voila. Today is Cassie's birthday. She brings a cake to work to celebrate with her colleagues, Stan, Gemma, and Rosie. Cassie unpacks the cake in the office kitchen. Suddenly, Granny calls, and Cassie goes outside to talk to her. After a while, Cassie returns and finds her precious birthday cake on the floor. She questions everyone. Stan says, "I was sending an important email, so I didn't look at the kitchen. But I think it was Gemma. She's just pretending to be your friend." Gemma says, "I went to the toilet to wash my hands. When I returned, the cake was already on the floor." And Rosie says, "I don't know what happened. I went to the opposite side of the room to turn on the coffee machine. I made cappuccino for everyone." Who's lying? The coffee machine is off, and all the coffee mugs are empty. Therefore, Rosie lied. She was busy doing something else while Cassie was away. Detective Bold is having lunch at his favorite cafe. He looks through the window and sees his neighbor Zelda rushing home. They both live next to the cafe. Suddenly, Zelda runs back and approaches the detective. Zelda: "Please help me. My apartment was robbed while I was out. I didn't touch anything. I just ran here right away to find you." Detective Bold goes to see the crime scene. He looks around and says, "Stop fooling around, Zelda. There was no robbery." How did he know? Take a look at this umbrella. Zelda carried it with her when she was rushing home, but she told the detective that she didn't touch anything at the crime scene. She just threw her stuff around the room to make it look like a robbery. Take a look at this fancy group of people. One of them is a real vampire. Can you guess who? It's the second guy. The first guy struggles with drinking this reddish beverage. The lady is just wearing a cosplay costume. And the guy on the right is taking a selfie, which means he shows up on camera. Therefore, he's a human being. Jeff calls the police early in the morning. Jeff: "My neighbor cut down a tree on my car." A policeman arrives soon. Policeman: "What happened?" Jeff: "My neighbor and I had a quarrel last night. When I was ready to go to bed, I saw him standing in front of my car. In the morning, I went out to drive to work and saw this. My car is pretty old, but he still has to pay compensation for the damage." The policeman questions Jeff's neighbor. He says, "Jeff is a bit weird. He's always trying to start a quarrel for no reason. I didn't touch the car. I was sleeping all night long." The policeman examines the car and immediately realizes which of the neighbors was lying. Who cut the tree down? Can you guess? Jeff. He cut down the tree with this axe. and then tried to put the blame on his neighbor to hit him up for money. Mike is an astronaut. His team consists of 2 other people. They're twins, Rob and Bob. They go to Mars for a month to study the local life forms. Time flies by quickly, and today they have to return to Earth. Mike goes to say hi to his little crew, but he finds 6 identical people in the spaceship. Mike realizes that the Martians can take any shape. Whom should he take back to Earth? This astronaut has 3 fingers. This guy's hair color is different. This imposter has forgotten to put on human ears. And this guy has different eye color. So the real Bob and Rob are over here. What's wrong here? The goalkeeper is holding a tennis racket. Also, why do they need 2 hockey pucks? Shelley downloads a dating app hoping to find new love. She likes several guys. They begin to chat and share some selfies. All 3 guys claim to be single and living alone, but only one of them is telling the truth. Can you guess who? The first guy sent Shelley a selfie from his bathroom. He's wearing a bathrobe. But there's another silk bathrobe hanging in the background. It's pink and small. Why would he need it if he's living alone? And the second guy is obviously fond of jewelry. He's wearing a ring on each finger, including the ring finger. So he's probably married. Only the third guy is telling the truth. And Shelley should give him a chance. A dangerous criminal escapes from prison. The police are chasing him, and the trail leads them into a small village. They question the locals and check the fields. Soon they see a farmer in a cornfield. The detective asks him if he had seen any suspicious strangers around. Farmer: "Sorry, I didn't focus on what's going on around me. I was too busy dealing with my corn. It's getting dark soon, and I need to harvest as soon as possible." The detective immediately figures out that this guy is the wanted runaway criminal. How? Corn is not harvested like this, so he can't be a real farmer. Can you see any odd details here? The phone is unplugged, and the laptop is missing a keyboard. Can you spot anything odd? Take a look at this guy. His fishing style is pretty weird. What about this scene? What are they doing wrong? This lady is skating on the pavement.
Voyager 1, which has been traveling through interstellar space for more than 45 years and is trailing a long gray beard by this time. Nah, not really. It suddenly began to send strange signals to Earth. Even more bizarre, there are no signs that the probe has broken or anything. Scientists from NASA are desperately trying to find the reason. So, what's happened exactly? First of all, let me tell you a bit more about Voyager 1 and its long journey. Voyager 1 is an American space probe. Scientists from NASA sent it into space on September 5, 1977. Voyager's goal was to explore the outer planets of our solar system, namely Jupiter and Saturn. Initially, scientists assumed that the mission would take about 5 years. Haha, the joke's on them. The probe exceeded all expectations. Not only did it fulfill its mission, but it's still working for much longer than expected. Voyager 1 has been wandering around space for more than 45 years. It's hard to estimate what Voyager 1 has done for science. Firstly, it successfully sent a lot of photos of Jupiter and Saturn to Earth. By the way, you can even check out these photos yourself. All of them are published on the NASA website. Thanks to Voyager, we also discovered several new moons of Jupiter and a previously unknown system of its rings. We learned that Jupiter's famous red spot is actually a giant superfast storm. And after leaving Neptune's orbit behind, Voyager also sent a lot of important data about interstellar plasma. So Voyager 1 successfully proved to scientists how useful it was. After that, it happily headed for its next goal, the Kuiper Belt and the heliosphere. The Kuiper Belt is a ring of icy bodies that extends from Neptune to a distance of approximately 50 AU from the Sun. It's kind of similar to the asteroid belt, but about 20 times wider and 100 times heavier. And the heliosphere is an area around the Sun where the pressure of the solar wind is balanced with the pressure of interstellar gas. Yeah, I know, it sounds like some hard scientific stuff. Just keep in mind that this data really helps us understand the universe as a whole. So, this is Voyager's last task, to tell us more about interstellar space. The probe has already sent us more than 60 frames for a mosaic of the solar system from a distance of over 4 billion miles from Earth. Scientists use these frames to make a big colored picture. The photo was called the pale blue dot, and you've probably already guessed what that dot is. Yep, that's what our Earth looks like through Voyager's eyes. This photo clearly shows how tiny we really are, and how precious and fragile our planet is. But Voyager 1 also has another, even more important mission, to tell other civilizations about us humans. You might have heard about the famous Voyager Golden Records. People created many audio and video files and added them to these records. There are a few sections. The first one contains hello in 55 languages, including ancient and extinct ones. Almost 80% of the recordings are different musical pieces, like Bach, Beethoven, Mozart, and Stravinsky, folk music from different countries and ages, and a bit of the blues, like famous songs by Louis Armstrong and Chuck Berry. The remaining 20% of the recordings contain different human voices, sounds of nature and animals, as well as 116 images encoded as audio signals. There's also recordings of speeches by Kurt Waldheim, a former UN Secretary General, and Jimmy Carter, a former US President. These are just some friendly messages. In addition to the records, scientists also packed a needle for playing them. Don't worry, they also left a simple drawing that showed how to use all this stuff and how to translate the sounds into pictures. They added Earth's coordinates, which they created using a pulsar map. It shows the position of the Sun in the Milky Way. The record was packed in an aluminum case and covered with gold to protect it against radiation and cosmic dust. Carrying this record, Voyager 1 set off on its long journey, and it has already traveled quite a distance, I'd say. Right now, Voyager 1 is 154 astronomical units away from us. That's about 14.5 billion miles. This makes it the most remote human-made object. Initially, this title belonged to the Pioneer 10 mission, but Voyager overtook it in 1998. What a bargain for NASA! It's way beyond its best-by date. Voyager 1 is actually so cool that it even overtook its twin brother, Voyager 2, which, by the way, had been sent into space 2 weeks earlier. Voyager 1 moves at a speed of 9.7 miles per second. That's 35,000 miles per hour. Even the fastest sports car in the world travels at a speed of only 305 miles per hour. So it's hard to imagine the speed of Voyager. Anyway, at the moment, Voyager is heading to the borders of the Oort cloud. That's the name of a hypothetical layer of icy objects surrounding the solar system. Astronomers haven't confirmed its existence yet, but they're almost sure it's there. After all, even black holes were only a theory not so long ago. Unfortunately, Voyager 1 won't return back to the solar system. It'll keep in touch with Earth at least until 2025. But eventually, we'll lose the connection with it for good. In 300 years, it'll reach the borders of the Oort cloud. And in 30,000 years, I won't be around then, it'll finally leave the solar system. And if nothing happens to it along the way, in another 10,000 years, Voyager 1 will approach red dwarf star Gliese 445 in the Giraffe constellation. In the future, the probe will probably keep wandering around the Milky Way galaxy. And now, let's finally discuss the mysterious signals part. So, what happened? Well, a rather unusual thing. NASA's Jet Propulsion Laboratory, which monitors and controls both Voyagers, reported this problem in May 2022. our veteran spacecraft suddenly began sending strange data to Earth. The whole situation puzzles even engineers from NASA. Now, I bet you're thinking, come on, the thing just probably broke down or something. But the truth is that Voyager 1 is totally fine. It works as usual, receives and carries out commands from Earth, and collects and sends scientific data. But the readings of the AACS, which stands for Attitude and Articulation Control Subsystem, don't show what is actually happening to Voyager anymore. This system supports the orientation of the probe in space and helps it keep in touch with Earth. So, basically, the signals mean that the probe's orientation in space is messed up. But scientists claim this is not the case. They know that the source of the antenna signal remains in the same position relative to Earth as planned. The problem hasn't triggered any of the onboard fall protection systems. The probe hasn't even entered safe mode. So, what in the world, or universe, is going on? Suzanne Dodd, the head of the project, says that the problem is not actually that unexpected. After all, Voyager 1 is already 45 years old. The expert admits that what's happening to the probe remains a mystery to them. They don't know exactly where the incorrect data is coming from, and it's unclear how this will affect the operation of Voyager. She adds, though, that it's not that surprising, considering that the probe is in interstellar space. There's a very high level of radiation there. No spacecraft has ever reached that point before. Scientists from NASA say they'll keep closely monitoring the data coming from Voyager 1 until they figure out the problem. If they find it, the management team will try to fix it. Otherwise, the team will have to adapt to the new conditions. It might not be enough just to understand the problem, though. It takes as much as 20 hours and 33 minutes to receive the signal from Voyager, and it takes the same amount of time to respond to it. Well, at least the second spacecraft, Voyager 2, is totally fine, even though it's also currently in interstellar space at a distance of 12 billion miles from Earth. Anyway, we can only wait for news and hope that the problem will be resolved. I actually wonder how much longer can Voyager 1 last? Will it be able to fly to the borders of the Oort cloud in 300 years? What do you think? I'd like to hear your thoughts in the comments.
Thousands of strange spaceships sneak into Earth's airspace. They descend to our planet and fly through cities, plunging people into complete chaos. Suddenly, the door of the largest ship opens, and a strange creature comes out. It tries to copy our language and says they had come from a distant star, Proxima Centauri. Something like this might happen because scientists have recently picked up a strange radio signal off that star. Proxima Centauri is the closest star to our solar system. It's only 4.2 light years away. That means a beam of light that starts from this star reaches Earth in 4.2 years. That's also 270,000 distances from Earth to the Sun. The star Proxima Centauri itself is too pale for us to see with the unaided eye in the night sky. But its system hides a little secret. Let's fly there and take a closer look. So here's this red dwarf. It's 7 times smaller than our Sun and 8 times lighter. Proxima Centauri is 1.5 times bigger than Jupiter and almost 150 times heavier. But what we're looking for is a little further away. This is Proxima Centauri b, a planet similar to Earth. It's only 10% larger than Earth and is in the habitable zone of the star. It's the perfect distance, not too far away and not too close. So the temperature isn't too high or low there either. Water, if it exists on that planet, can be in a liquid state. And so, life can survive and evolve there. Maybe it's developed enough to send us the signal that we had received. A radio signal is basically waves. They have a certain frequency and length, and we can always tell an artificial signal from a naturally generated one. The signal that we picked up from Proxima Centauri b had a frequency of 982 megahertz. The regular radio we listen to in the kitchen or in the car picks up signals around 100 megahertz. That's why scientists have concluded that the signal was created artificially. Such signals could have a way of communication between the developed worlds. If this is really a message from an outer space civilian, we should be able to decode it. For this, any civilization must use the simplest method of encryption. For example, Earth has already sent a radio signal into space. It was the Arecibo message. This message consists of 1,679 digits. It's a rectangle of 23 by 73 squares that has information about our civilization encoded using a binary code. At the top of the rectangle, there's a system of numbers that we use. They're marked in white. This purple thing is the key to read the next part of the message. The atomic numbers of the elements like hydrogen, carbon, nitrogen, oxygen, and phosphorus are encoded in this key. These are the key elements that can start life. If those who receive this signal can make sense of the numbers in the key, they can read the next part of the message. These green things are the building blocks of our DNA chain. And right at the bottom here is the DNA chain itself. The white rectangle indicates the number of pairs of these building blocks, and the blue spirals show the shape of a DNA chain. And then we see the human silhouette itself. The white and blue object to its left is a coded number of our average height. The human itself is drawn here at the ends of the DNA strand, so that the outer space civilization can understand what we look like. And the white rectangle to the right of the human sketch is the number of Earth's population at the time of the message. That's 4.2 billion as of 1974, almost half the number we have now. The next part is a drawing of our solar system. The big yellow square is the sun. Then come all the planets in our solar system, including Pluto. Earth is shifted up a bit here, so that outer space civilization can understand where this message is coming from. In the last drawing is the observatory from which this message had been sent into space. This signal is now on its way to the M13 star cluster 25,000 light-years away from Earth, so it won't get there for another 25,000 years. And we'll need another 25 to get a response if there is really someone on the other side who can receive the signal. If the signal from Proxima Centauri is also a message, we'll need time to decode it. So let's fire up our super-powered computing machine and wait for the result. But this isn't the first mystery signal we've ever picked up on Earth. Scientists recorded an unusual wow signal in 1977. They supposed it came from somewhere in the constellation of Sagittarius. The telescope was picking up the unknown signal for an impressive 72 seconds. Later, a scientist who looked at the printout of the signal concluded that the signal was artificial. He wrote, "Wow," on the printout as his reaction. The following observations and studies couldn't catch this signal again. Some theories said that this signal came from a celestial spaceship flying by. It had flown away, and we could no longer detect the signal. But most likely, this signal was created on Earth. It was directed upward but reflected off an object at a high altitude. It could have been an airplane, a satellite, or space debris orbiting our planet. Then the signal was picked up by the telescope, and because it was human-made, all of its characteristics, like wavelength and frequency, could have confused scientists. In 2017, scientists recorded a flare on Proxima Centauri. The star's brightness increased by 1,000 times in just 10 seconds. Before that, there was another flare there that was weaker but lasted about 2 minutes. With these flares, Proxima Centauri has emitted enormous amounts of radiation. Even if there was life on the star's companion planet, these flares would have likely destroyed it. The stellar winds would have simply blown the atmosphere off the planet and made its surface lifeless. Overall, the planet Proxima Centauri b receives 60 times more high-energy radiation and 400 times more X-ray radiation than Earth. Scientists have concluded that the probability of life here is 1 to 100 million. And while we don't know yet for sure if the signal was artificial or natural, the scenario of a bunch of spaceships coming to Earth is most likely possible. Our only method for searching for outer space civilizations is using radio waves. They're like loud noise that blasts away from our planet in different directions at the speed of light. The main problem here is the gigantic distances. Our galaxy, the Milky Way, is 100,000 light-years wide. Suppose there's life at the other end of it. If we send a radio signal to them, it won't reach that supposed planet for another 100,000 years. And we won't get a response for another 100,000 years. It's the same if someone once wanted to contact us. We didn't learn how to create and receive radio signals until the 19th century. If a civilization was developing at the same time as us somewhere in the Milky Way and they invented the radio, we won't get their signal for several millennia. Plus, the radio noise from our planet is starting to fade away. We use Bluetooth, fiber optics, cable TV. So in about 100 years, we'll no longer be visible to other worlds. Or worse, what if there was an outer space civilization somewhere that was sending signals into space? The signals were reaching our planet, but we didn't yet have the technology to pick them up. The world that was sending the signal has evolved, and the signal went out. We could have caught those remnants of the radio waves that were moving through the universe. but we set up the antennas too late. There are about 2 trillion galaxies in the universe. Each of them contains billions and trillions of stars similar to our sun. Maybe there's a planet near one of them that looks like ours. Life could be blooming there. And this outer space civilization, just like us, is looking through telescopes in hopes to catch the radio signal from an unknown planet.
Weird, unusual sounds out of nowhere are spreading all over our galaxy, constantly repeating, and it's something we've never heard before. Scientists discovered it in 2020, and it was nothing like any of the other energy signatures they ever studied. Powerful and bright radio signals occurring from time to time, mysteriously disappearing within a day. It doesn't fit the profile of any space body we know. The signal is a bit irritating, and it disappears without a schedule. When scientists tried to match the signal with some other telescopes, it was gone. Low-mass stars sometimes flare up with radio energy, but not here, since they mostly have X-ray counterparts. Very dense collapsed stars, like pulsars and magnetars, are also not a choice. The closest solution they got is a mysterious class of objects we know as the Galactic Center Radio Source, GCRT. It's a radio source that brightens and rapidly glows. It decays near the center of our galaxy and could help us unravel the mysteries of the universe. If you had a flying car that could go up at a speed of 60 miles per hour, you'd only need 1 hour to get into space. The moon is a little bit farther, 250,000 miles, which is about 10 times the circumference of our planet. That means a moon trip would be like taking a tour around the globe and doing it 10 times straight, which would take less than 6 months. A trip to Pluto would take over 800 years. Proxima b is the closest Earth-like neighbor we have. It's a small rocky world that orbits the closest stellar neighbor of our Sun. It orbits the star's habitable zone, an area that's far enough from any star to have moderate conditions, not too cold and not too hot for liquid water to at least hypothetically exist. If you tried to travel to Proxima b at a speed of 25,000 miles per hour, which is the speed of the Apollo moon rockets, it would take you over 112,000 years to get there. You might not be able to breathe there. No one knows if Proxima b has an atmosphere. Humans explore the universe all the time, but we can only see around 5% of the matter up there. And Albert Einstein was the first one that realized the empty space is not really nothing. The rest we can't see is actually made up of invisible matter, also known as dark matter. It's about 27%, combined with something called dark energy, which is 68%. If you try to pour water into space, of course, outside of a spacecraft, it would immediately boil away or vaporize. That's because there's no air or air pressure in space. As air pressure lowers, the temperature you'd usually need to boil water at also gets lower. Keeping that in mind, water boils way faster on a mountaintop than, for example, at sea level. There's no air pressure in space, so water could boil at a very low temperature. Scientists believe that there are at least a couple of billion galaxies out there. We don't know the real number, and probably never will, but they tried to calculate it by counting how many galaxies we can see in a pretty small and restricted area of the sky. It may seem as if the universe was filled with stars and a couple of planets here and there, but our home galaxy has at least 100 billion planets. If you fill a balloon with helium and release it, you'll notice it floats very high. It'll go up into the atmosphere, but it won't go into outer space. The higher you go, the thinner the air in our atmosphere gets. Your balloon will rise up until the point where the atmosphere surrounding it has the same weight as the helium inside it. That will happen at approximately a height of 20 miles above the surface, so this is as far as a helium balloon can rise. We don't really know how big the universe is. We can't see its edges, nor do we know if it even has an edge. We use technology to see out to a distance of around 14 billion light-years from our planet. This means we can see around 28 billion light-years in diameter across, starting with the outermost layer of our atmosphere that ends at around 600 miles above our planet's surface. Although the size of the universe is constantly changing and gets bigger through time. Mercury is closest to the Sun, so most people think it's the hottest planet too. Still, Venus is the hottest planet. It's the second planet away from our central star, around 30 million miles farther from the Sun compared to Mercury. Mercury doesn't have an atmosphere, which is like some sort of a warming blanket that helps maintain the heat coming from the Sun. Venus has an unexpectedly thick atmosphere, around 100 times thicker than the one we have. Its atmosphere doesn't let the heat out, it just keeps it, and constantly makes Venus hotter and hotter. Also, it mostly consists of carbon dioxide that freely lets solar energy in. But it's less transparent to lose long wavelength radiations that the warm heated surface emits. The average temperature there is around 875 degrees Fahrenheit, which is hot enough to melt tin. The maximum temperature on its neighbor, Mercury, is 800 degrees Fahrenheit. In maybe 2 or more billion years, it will be way too hot for life to exist on our precious planet. As the hundreds of millions of years go by, our sun will keep getting hotter and brighter. Eventually, temperatures will be so high, our beautiful oceans will be wiped away. Since they produce 70% of the oxygen we need to survive, there'll be no life without them. All of this means that our planet will simply become a vast desert, something like Mars is today. Pluto, a very distant used-to-be planet, now dwarf planet, is actually smaller in diameter than the entire US. The biggest distance there, from Maine to Northern California, is approximately 2,900 miles, while Pluto is only 1,473 miles across. Pluto is very far, but the edge of our solar system is 1,000 times farther away than this dwarf planet. But astronomers found many space objects orbiting our sun way farther than Pluto, such as Kuiper Belt objects and trans-Neptunian objects. There's also an Oort comet cloud that goes half a light year from Pluto, also 1,000 times farther. A neutron star is really heavy. Just a teaspoon filled with it would weigh 6 billion tons. Neutron stars are something that remain from huge stars that have run out of fuel. The fading star explodes, and its core falls apart, but due to gravity, it forms an extremely dense neutron star. These stars typically have a mass of up to 3 suns, but the radius there is around 6 miles, because this is one of the densest things in our universe, at least that we know about. The universe has a color, and it averages to be some kind of beige, or as they call it, cosmic latte. It also has its own smell that reminds you of seared steak or hot metal. At least, that's something astronauts floating in space have said. If you want to build a spacesuit, get ready to work really hard. It takes 5,000 hours to make it and will cost you $1 million. A really good one will have 11 layers of material and weighs about 110 pounds, and it needs to be comfortable. You'll need more space in there because you grow up to 2 inches when in space. When you're floating around in space, Earth's gravity doesn't have any impact on you. That's why the vertebrae in your spine might expand and relax a little bit, which means you'll be maybe 3% taller. For 6 feet, it's about 2 extra inches. Oh, don't worry, it's not permanent. As soon as you go down to Earth, you'll shrink back down to your normal size within a couple of months. Space isn't the best option if you want to have a conversation with your friend, because up there, sound doesn't travel at all. Molecules there are so far apart that sound vibrations can't reach them, which automatically means they can't vibrate, so we can't hear them. Movies are not accurate with this. No one could hear you screaming in space, too. We kind of live inside our sun. The sun is not just that big hot ball of light located 93 million miles away from us. Its outer atmosphere is way bigger. It extends far beyond the surface we can see. Our planet's orbit goes through its tenuous atmosphere. The evidence is when gusts of the solar wind generate the southern and northern lights. That means, in some way, we live inside the sun. Not just us, other planets too, including distant Neptune.
The heliosphere, which is what we call the outer solar atmosphere, extends to about 10 billion miles.
Hey, wake up! Quick, listen to that. It's a 5-second FM signal coming from one of Jupiter's moons. You fumble for your phone and inform your colleagues. They freak out over the news and rush to the lab. You've been a scientist working with the Juno probe, exploring Jupiter for years. But this is the first time you've witnessed something so unusual. Ganymede is Jupiter's largest moon and the biggest moon in our solar system. If this space body didn't orbit around Jupiter, it would be classified as a planet. It's even bigger than Mercury and Pluto. What makes this moon stand out among others is the fact that it has its own magnetic field. The moon was born around 4.5 billion years ago. It means it's as old as Jupiter itself. This planet-sized space body takes 7 Earth days to orbit its planet. Everyone gathers at the laboratory, impatiently waiting for you to play the recording of the signal coming from space. Your colleagues get their game on, trying to figure out what the source of this mysterious sound is. Around 40% of Ganymede's surface is dark, with craters scattered around, and 60% is light-colored. There are formations that were probably caused by tectonic activity or the release of water from under the surface. Scientists managed to discover a thin layer of oxygen trapped in the moon's atmosphere. The temperatures there are super low, between -170 to -200 degrees Fahrenheit. There isn't much information about how the moon behaves or what chemical elements it hides inside. Some of your colleagues try to create the same conditions that existed when the sound was transmitted. For hours, they sit there waiting, but nothing. Maybe it was a fluke. You get to the control system and activate the Juno spacecraft. The main point of this mission is to observe Jupiter's gravity, magnetic fields, the atmosphere, and the planet's evolution. By the way, there's also some evidence that Jupiter's largest moon is evolving too. Since it has a magnetic field surrounding it, auroras pop up all the time. Those are glowing gas circling the moon's north and south poles. If life existed in such a place, it would probably be at the bottom of Ganymede's extremely salty ocean. For a long time, scientists thought that the sun was a crucial component to kickstart life. But now we know that there are organisms dwelling deep at the bottom of the oceans. Those are doing just fine without sunlight. The oceans of our planet are teeming with some of the most bizarre creatures of all shapes and sizes. Sea lilies live some 10,000 feet underwater. They got their name because they look like flowers, except they're not plants, but animals. Don't be fooled by their stems and leaves. Those are body parts equipped with nerve endings to detect food around them. Goblin sharks are probably some of the most weird-looking sharks that live at the bottom of the ocean. They can grow up to 12 feet long and have a very unusual snout. Now, take a look at the anglerfish. It has a bioluminescent blob on its head to attract prey and navigate its way around the dark ocean floor. It's a natural flashlight that never needs new batteries. It's only the females that have these flashlights, though. The blobfish is another bizarre animal living down there. It lives in the Atlantic, Pacific, and Indian Oceans, 9,000 feet under the surface. Anyway, even though you asked everyone to keep the news confidential, it somehow leaks to the media and becomes a new trending topic. You get a call from a news agency. They say they want to interview you about this breakthrough that may prove life exists in outer space. The next day, you head down to the news station to talk about your discovery. You have a whole live studio audience watching your every move as you reach out to grab your glass of water. The crew scurries around doing some last-minute checkups before you're live on air. The makeup artist does some final brush-ups. The sound engineer asks you to test your mic once more. Several of the producers are sitting in the front seats. Bright lights are flooding the studio. The countdown begins. 3, 2, 1, and you're introduced. And the host asks you to explain what it was that you heard. You tell them about the Juno space probe orbiting Jupiter. After a couple of questions, the host finally brings up the most dreaded one. Might the mysterious sound be coming from another civilization? Everyone leans in, waiting for you to answer. You freeze, not knowing what to say. Even though the crushing pressure at the bottom of the ocean is 1,000 times stronger than at sea level, life still exists there. Algae, which is considered a delicacy in the ocean world, is off-menu for deep-sea creatures due to a lack of sunlight. Many of these bottom dwellers have to munch on leftovers instead. Those sink down there from the upper layers of the ocean. The freezing temperatures and the intense pressure have altered the cells of these creatures. This has made them more resilient than the average fish. Bacteria were developing their own ways of surviving. Studies show that they feed on certain gases and chemicals, like sulfur and carbon dioxide. Methane and hydrogen are released when tectonic plates move against each other, and some of these bacteria feast upon those gases too. Tardigrades, also known as water bears, are microscopic critters that can live and thrive in extreme conditions. You can find them in volcanoes, frozen glaciers, and even in the empty void of space, which means that some life forms might actually exist on Ganymede. You explain this to your audience. Then you mention that you don't have enough information to determine if it was another civilization or a natural phenomenon that produced the sound. This doesn't mean that the bottom of Ganymede's freezing oceans isn't teeming with its own bizarre and weird creatures. There might be some legendary beasts like the kraken or leviathan there, or weird glowing fish with two heads, a fish with tentacles and a large fin, giant crabs. The bacteria there might be as varied as our own. The plants, if they exist there, have to be strong enough to survive the sub-zero temperatures. The animals on Jupiter's largest moon could be as big as our blue whales or as tiny as plankton. After the interview, you head back to the lab to examine the records once more. On your way home, you see posters of yourself with captions like, "Are we not alone?" Hey, you've become a celebrity. Many people take pictures of you. You've been booked by other agencies for more interviews. Some science magazines even want to put you on the front cover as the Person of the Year. Every time you come to work, you wait for the sound to appear again. But nothing. You send a signal from the Juno probe, trying to make some sort of contact with whatever produced the sound. Nothing. That night, you pass out on your desk once more. Eureka moment wakes you up in the middle of the night. There might be something you've missed. You run the numbers again and realize that the answer was in front of you this whole time. It wasn't another civilization that produced this sound. The source was electrons. Every planet produces its own sound. It's created when charged particles from the solar wind and the planet's magnetosphere interact with one another. That's what happened on Ganymede. The electrons in its magnetic field, where the probe picked up the signal, were acting stranger than usual, and this amplified some irregular frequencies. You're embarrassed and spend the rest of your night making phone calls, telling your team the news. The agency that interviewed you releases a statement. They explain that other civilizations aren't trying to contact us. You sit back at your desk, waiting for the next big thing to happen. Europa is another of Jupiter's moons that may host life. It's made up of an iron core, a mantle, and a salty ocean, twice the volume of all the oceans on Earth. And just like Ganymede, the ocean lies under a water ice crust. Scientists claim that there might even be active volcanoes there, and some resilient bacteria may live there. With enough water, certain chemicals, and a source of energy, Europa could produce life. But it's unlikely that we'll find anything but tiny microbes. Venus has more volcanoes than any other planet in the solar system, more than 1,600. And a day on Venus, measured by how long it takes to rotate once on its axis, takes longer than the time it takes to complete a full orbit of the Sun. Wow! And that's just Monday. An extreme greenhouse effect warms the planet's surface up to 870 degrees Fahrenheit, hot enough to melt lead. Winds there reach the speed of 450 miles per hour in the middle cloud layer, faster than the speediest tornadoes on our planet. The pressure on Venus's surface is 90 times higher than that at sea level on Earth. What a great place for a vacation, huh? And recently, this incredible place has become even more intriguing. In the toxic Venusian atmosphere, there's something that might mean the existence of life. Unfortunately, scientists haven't had a chance to collect any microbe specimens or snap any pictures of life there. But they've discovered a chemical called phosphine, and it's a big deal.
If it's not some previously unknown chemistry that produces the gas, then there must be a kind of microbial life involved in the process. Phosphine is made up of 3 atoms of hydrogen and 1 atom of phosphorus. This gas is toxic to any normal life form that needs oxygen, including us humans. On our planet, phosphine can be found in places with no or little oxygen. For example, marshes and swamps. The gas is created by complex mixtures of bacteria living there. It can also be produced industrially.
The weirdest thing is that phosphine isn't supposed to be in Venus's atmosphere at all. This gas needs precise pressure and temperature and tons of hydrogen to form. It wouldn't be all that surprising to find it on Saturn or Jupiter, the famous gas giants, but on Venus, totally unexpected. There's no way phosphine can be produced naturally on this planet. Tiny amounts of it can be created during volcanic eruptions, lightning storms, minerals blown up to the surface, or meteorites entering Venus's atmosphere. But it's not nearly enough to explain what the astronomers have observed. It would only make 1/10,000th of the phosphine the telescope saw.
But let's start from the very beginning. In 2017, a group of scientists led by Jane Greaves from Cardiff University started to use the James Clerk Maxwell Radio Telescope in Hawaii. That's a mouthful. The main idea was to search for phosphine gas. It would be a sign of life on Venus. When the data came back and the researchers analyzed it, they were shocked. The phosphine signal was powerful. The team checked the results several times. They wanted to make sure no other substance mimicked the presence of phosphine gas.
So now, does it mean there's life on Venus? Well, not necessarily. If this gas is created by some mysterious organisms, it's a big question how they survive on Venus. On our planet, some microbes can thrive in the environments with the acidity of 5%, but no more. On Venus, though, clouds are almost entirely made of acid. And even though they have a rather pleasant temperature of 86 degrees Fahrenheit, these clouds contain more than 90% of sulfuric acid. DNA, amino acids, proteins, life components on Earth would be dissolved there in the blink of an eye. The surface of the planet is too hot for any kind of complex molecules to make up life. The Venusian atmosphere is almost 50 times as dry as the driest place on our home planet. There's a theory that microbes might hide in scarce water droplets floating in the atmosphere, but it hasn't been proved yet.
Right now, the research team's waiting for more telescope time. They're going to look for other gases associated with life. But even if they find more evidence, life forms on Venus will be made up of building blocks absolutely different than those on Earth. Or they might be protected by a sulfuric acid-resistant shell. It can be made of such substances as sulfur, wax, graphite, or something else we can't imagine.
Of course, some experts question the idea of life on Venus. They think the gas might be produced during some geologic or atmospheric processes happening on the planet. But the supporters of both theories agree on one thing: the discovery is extraordinary. Interestingly, astronomers have always tried to find signs of life on giant planets' icy moons, or even closer, on Mars. But they've never seriously considered Venus. If additional telescope observations and future space missions confirm that phosphine is produced by living organisms, we can be in for a bunch of exciting surprises. Then people would know of a planet with an alien biosphere, well, alien to us, and this planet would be just next door to Earth. Now, speaking of visiting Venus, though, would it be possible for people to land on this planet? After all, robots are already tooling around the red planet surface. On the pro side, Venus is closer to Earth than Mars, but it also has much harsher conditions. The planet is hotter than Mercury, even though Venus is almost double the distance from the Sun. The temperatures are higher than the melting point of many metals, and some of them, like lead or bismuth, can fall as snow on the highest mountain peaks. If you set foot on the planet, you'll find nothing but barren rock. Giant basaltic plains are littered with volcanoes and mountains. In some places, the surface melts because of the heat underneath. After it releases some of it, the rock solidifies again.
If people ever go to this planet, they will most likely build floating cities in the clouds of Venus's atmosphere. At about 31 miles above the surface, the conditions, like the pressure and gravity, are similar to those on Earth. The temperature is rather manageable too, at around 167 degrees Fahrenheit. Think Death Valley, California on a really hot day. The atmospheric pressure is half of what we have at sea level on our planet. If you went outside, you'd be fine without a pressure suit. The pressure you'd feel would be the same as at the top of Mount Kilimanjaro. Plus, this colony would be protected from the sun's radiation better than one on Mars.
If the atmosphere was the mission's final destination, landing a spacecraft, or rather making it hover in the air, would look very different. The idea is to use an airship in the upper atmosphere for long periods of time. The airship, wrapped in an aeroshell, would enter the planet's atmosphere at a speed of 24,000 feet per second. In the next 7 minutes, its speed would drop to around 1,500 feet per second. After that, a huge parachute would open. It would slow the spacecraft down even more, and then things would get a bit hectic. The aeroshell, not needed anymore, would drop away. The airship would then inflate itself, all the while hurtling through the atmosphere toward the planet's surface. Its speed would be at least 330 feet per second. It would get larger and larger, and its drag and lift would increase. Soon, the parachute wouldn't be needed anymore. The crew would get rid of it, and the airship would fill with air completely. If everything went as planned, it would stop 30 miles above Venus's surface. After that, the airship would travel around the planet. It would be moved by the wind, which can reach a speed of 220 miles per hour at the top of the cloud layer. If you decided to move closer to the surface, though, you'd have to be extremely careful. The wind in the middle layer can get twice faster. The airship could be filled with a breathable mixture of hydrogen and oxygen gases. Such a combination would be less dense than the Venusian atmosphere. It would provide the needed buoyancy, to stay up there. Venus is famous for its super dense clouds. These clouds make the planet shine bright enough to be seen from Earth. Venus reflects more than 75% of the light that comes from the sun. This reflective cloud layer exists thanks to a haze of sulfuric acid droplets in the atmosphere, and they gather exactly at the height where the airship would float. Luckily, people already have a method to overcome the problem of acidity. A few materials, for example Teflon and some types of plastic, have an amazing acidic resistance. They could protect the outsides of the ship. So, let's say you needed to work on a platform outside. Then you'd be able to do it, wearing only a chemical hazard suit and carrying necessary oxygen supply. Ooh, sounds like fun, huh? Yeah, me neither.